There we go. So apparently we all need to use a handheld, just be aware of that. Just some housekeeping. Is everybody who's supposed to present, well, I guess I better just put up the slide in a second. Could you just bring up the slide? I'm pressing the green button, presumably. Okay, so this is the session. You're welcome if you intend to learn more about migration futures. And some of the rationale that Carson, this was actually 2 sessions that were combined into one, but very harmoniously. Unlike some other sort of forced marriages, Carson and I got along wonderfully. and we really had the same vision for the session, so that was perfect. So we know that the migration has been part of the SSP scenarios of population projections for a long time. They were implicit. They were largely kind of using UN extrapolated bilateral flows models to understand what populations might be in countries in the future, and they needed, of course, incorporate migration into that. But more recently, there have been increasing efforts to explicitly model migration based on SSPs. Where did, can you go back to that former slide? There we go. Okay, I'll do the controls from here, if you don't mind. Relative to fertility and mortality, we know that migration is the most dynamic of the demographic balancing equation variables. So it's actually not an easy matter to project in a very confident way migration, but there are nevertheless those who, they say that fools walk in where angels fear to tread, and so there are those of us who have actually attempted to do this in more systematic way. This session will provide a forum to discuss scenario-based migration research combining SSPs and RCPs from a variety of perspectives and to enable a transdisciplinary exchange of migration scenarios, including but not limited to social and political scientists, demographers. So we have a very diverse group of presenters today, and I will go to the next slide to list the presenters. This is not responding. Do I point it in some direction? There we go. So we have, I'm not going to list everybody, but I would like to just see, Carolina's here, I know. Mikhail, could you raise your hand? Thank you. Lucas, could you raise your hand? Roman, we know, is here, and Hélène. So everybody is here and accounted for. And so I think we're going to have a very rich set of presentations today. We wanted to keep each presentation to 12 minutes so that we'd have sufficient time for discussion. And I think, as usual, we'll have some very quick questions after each presentation, related specific clarification questions, and then we can get into a broader discussion about what works and what doesn't in this space of migration modeling. I'm going to use a yellow for 2 minutes left and red for 1 minute left. Maybe this will be 2 minutes and then the red will be time. And when you see that red, that means you really should be wrapping things up. So with that, we'll move right into the first presentation by Carolina. So we welcome you up here, Carolina, and looking forward to hearing what you have to say. There you go.
Thank you very much. So waiting for the presentation, I will just, again, introduce myself. My name is Karolina Sobczak-Szelc, and I am from Center of Migration Research at Warsaw University, and as well from Kaspar Krakow Economic University, both in Poland, but I believe that all of you knows it already. And today I was asked to present or give an input about the role of qualitative research in creation of storyline. Of the shared socioeconomic pathways, and I'm going to do this on the example of 3 case studies in Tunisia. So after 2 days of the conference, there is no point in explaining SSPs anymore. So this is I'm going to skip and go back more into actually drivers of migration. And already in 2011, so quite ago, Bilateral identified 5 families of drivers which affect migration decision. And these are political, social, demographic, economic, and environmental. And they argue that those factors, those drivers, actually cooperate with each other. And the role of environment depends on the remaining. And here I would like to underline that within my research, I always focus on the environment, not only on the climate, because climate is a part of the environment. And actually what is felt by people in field is change of the environment, which is much more direct. And local circumstances play a major role in the migration process. They give opportunities for both mitigation and adaptation, not only actually to environmental pressure, but also to general change of socioeconomic situation, which is the direction for the environmental change. And as we already know and have discussed during the last 2 days, such complex relation between those factors makes it extremely difficult to model. And therefore, the qualitative research on microscale may be considered a small-scale laboratory for such policy recommendations. And having this in mind, I would like, the aim of my today's presentation is threefold. Actually, the first one is to discuss the multidimensional factors that cause migration and how far the interactions play out in different rural and urban areas. Then I would like to explore somehow different relations between environment, political, social, and historical factors, and how they influence migration decision. And finally, it's kind of exercise, actually, because listening presentation through last 2 days, I would like to check whether those case studies which I investigated can be categorized according to those scenarios, or actually local level should only deliver information on the complexity of factors that should be included in those scenarios. So as a research area, I have chosen 3 case studies: El Fawer and El Fersh oases, rural areas in southern Tunisia, and city of Sousse. And one thing which I have not said at the beginning is that research in El Fawer and El Fersh were conducted within the project financed by Polish National Center, Determinants of Environmental Migration in Northern Africa countries. And Sousse city was investigated under the project financed by within H2020 project, Future Migration Scenarios, where Carsten is a leader. And that were 2 projects, slight differences between methodologies can be found here. So within rural areas, I've implemented mixed method approach. I started with desk research, environmental field studies, and we interviews with local actors, and that gave me input to look more into or adjust questionnaires, and then in-depth interviews with household, heads of households. Then within city of Sousse, we also started with desk research, and we had interviews with local actors that were followed by in-depth interviews with potential migrants to Europe. And additionally, we have done also non-participant observation. So in general, in order to give the input to the migration scenario narratives, I framed kind of decision-making process made on the level of household. And I wanted to look at this through the history lens, to look how decisions on adaptation mitigation strategies changed in time. And in time in rural areas, I understand time from the beginning of the oasis, and in city, it's the time from the arrival. So let's start from El Fawer oasis. The oasis was established in the 1960s, and actually from the early beginning, it faced population growth and environmental changes. Because of the fragmentation of land, like a lot of children and so on, the households quite quickly realized they have insufficient income from agriculture, and they increase the area they cultivated. So, but quite soon they realized that having one well, which is 100-meter depth, it's not sufficient to water all fields there, and it influenced the quality of crops there. So there was a need for new water wells, but that needs new money resources. And here we have kind of vicious cycle, because new wells caused further degradation of the environment because they were getting drought, and expanding of fields demanded new wells, so new resources were needed. And those resources were usually, so those adaptation, were usually from immigration or mobility, either to big cities of Tunisia or to abroad, where people were looking for additional resources. So in other words, migration became part of adaptation strategy, and it allowed for both development and increase of resilience. And within this exercise, which I tried to make, I would put somehow the example of Elfauer as give input to the fossil fuel, so SSP5, as the migration plays a huge role in adaptation strategies. And there are much more bigger issues with mitigation challenges. And so let's move to El Fersh. The IIASA was established in the same time. However, as it was established on the areas with fertile lands and shallow wells, so as shallow access to the water resources, it developed cultivation of vegetables. In 1990s, the oasis was connected to the electricity, and it changed quite a lot because it allowed for intensification of agriculture and extraction of water resources, actually leading to degradation not only of water resources but also of soils. And together, because it's Tunisia and like Northern Africa in that time, not only Northern Africa, but faced population growth. Also here we have a population increase, fragmentation of cultivated areas, limitation in income from agriculture, and strong need for immigration, and additional sources of income. This is also like interesting case study because here like the tradition of migration is much longer. In 2004, new water sources were delivered to the oases. However, actually, they have not changed a lot, which will be in a minute. And like giving just two quotations from that area, which shows the one of the on the left actually shows that environment, the role of the environment in decision-making process, because the brother of the interviewee said that he's not able to manage in such difficult environmental conditions with the agriculture. The other shows actually the change in aspirations, the change in culture of youth who are not willing anymore to work in agriculture. And furthermore, they are not finding appropriate job possibilities in the area. They are seeking migration or mobility. So here, like a fetch give us show us somehow that the scenarios, what we was also talking about yesterday, may change in time. So even if we started with somehow SSP5, then we can move to like more inequality within the society, because those who are not all households have access to new water resources. There is not all households have someone who is abroad, and not all households have a possibility to increase the arable land. So let's move to the final stage. It's a city of Sousse, and this one was chosen as an important destination point in internal migration, but also as a significant starting point or even stepping stone for international migration. And research in city actually allowed to look closer at the fragmented trajectories and the possibility to compare changes among migrants and their motivations which came to the city in different time. And here, Sousse city showed very clearly the role of time in change in migration decision and how the approach towards migration. We were looking at settled migrants who came to the city looking for better life perspective, and international migration actually was perspective for their children. Newcomers, so those who came during last 5 years, actually are looking for, not finding the opportunities in the city. They want to go abroad as fast as possible. And in this case, city is like a missing puzzle in our puzzle master, because from the one hand, it shows, depending on the city, different adaptation or mitigation strategies can be implemented in areas of origin. On the other hand, especially for youth, this city can become also a region of origin and show that the story actually begins there. So just to conclude, those studies contribute to the theoretical debate on the creation of scenarios, showing that when it comes to the individual decision to migrate, or actually not, the qualitative field studies complement the work over models, describing a variety of development pathways that might be used to specify particular SSPs. Research and recommendations on micro and meso level allows for better suited mitigation and adaptation policies, which is not possible on national and global dimension. And just a final sentence from my side. Actually, from my point of view, any one-size-fits-all approach to projecting future international migration, especially in climate change context, can be highly misleading and actually lead to wrong policy answers. In such differentiated circumstances, of course, scenario framework is helpful and is necessary. However, to think about any policy answers. However, local case studies and inclusion of local context is necessary not to actually destroy more the area that we are talking about. And I will finish here. Thank you very much.
You were 12 minutes on the dot, which is perfect. If there are any questions for Carolina or considerations that anyone wants to raise. Yes, Raya. Oh, sorry, Raya, you need to speak into a mic.
Sorry, I don't quite understand why migration is seen to be linked with SSP5. Yeah?
The one from Elfauer and Elfersh, like at the beginning. Because like, if I understand, I am not an expert in SSPs. I think that all of you know more than I do, although I have learned quite a lot. But like, according to my understanding, even if SSP is a pathway, and it has some kind like general frames, within both at the beginning of Elfersh and Elfauer, we had like strong or intensive exploitation of resources, which is water. And at the same time, we had like migration, which was part of adaptation. And here, so possibilities for adaptation were high. And in the same time, the limitations for mitigation of consequences of changes were like lower. They need to adapt, they're not able to cope without adaptation.
Hi, thank you for the presentation. I fully agree with the framework, and I think your results are very interesting. But I was wondering whether you could not make your case stronger by adding some quantitative research to it. So, like when you talk of, I mean, you probably hear this comment a lot, but when you talk about population growth or like unemployment, or whether like having some numbers on this would not help your case.
Definitely, yes. I had just 12 minutes. And like I have published a paper from the case of Elfauer and in comparative migration studies. So this one is available. There's nothing about SSPs, but it actually in detail explains the situation there. Like Elfersh is still waiting for the time to write it, but I think that in September, October, we'll publish also the report from research in Tunisia, which was one of 4 case studies we were investigating as qualitative origins, and 3 others were Dakar in Senegal, Dahouk in Iraq, and Kiev in Ukraine. And there, this demographic or quantitative background is very much more developed. And also, as you could see from methodological sections, in both rural areas, I started with questionnaires. It was not among all households there, but it was sufficient to understand the biggest risks and the context there.
If I could just add, one of the advantages I see of your approach is we tend to think of the SSPs like regional rivalry or these sorts of things, or divided world, as being blocks but it really comes down to individuals. People don't live their lives as blocks. They live their lives as individuals, and their individual experience of inequality and things like that is something that's very important. Are there any other pressing questions? Otherwise, I think we will move on to the next presenter, who happens to be Mikhail, who's right here. So thank you.
Thank you very much.
And thank you, Carolina. Let's give a...
All right. Let's see how this works. Oh, I guess the green is forward. And yeah, I changed the title a bit, so it's not the same as in the program. We tried to answer a very, quite a simple question in this, with this paper. How to quantify migration narratives. I think that's something, at least, that from what I could see during the last 2 days, that's being done quite regularly in research on climate change, not so much in migration. So there is actually one other study that we could find that aimed to do the same. It's not been peer-reviewed yet, but this is what they did. They came up with 4 scenarios, so using this axis, they were, we'll just go back. So this study that we found was based on a handful of studies that were published mostly by OECD and other supranational organizations that elaborate narratives of the future, about the future of migration. And based on this literature, so the paper of Acosta Madiedo came up with these 4 narratives. The 4 narratives were defined by the 2 drivers, economy and international cooperation. And that's what we kept seeing again and again in the published literature. 4 scenarios based on these on change in these 2 drivers. And so what the authors did, they asked experts to quantify the amount of change in terms of migrant numbers associated with each narrative. So, as I pointed out, so there's a few assumptions, I guess we could say that this approach makes. So the first one is that economy and international cooperation are the most 2 important factors driving migration. Another one is that change in each driver is equally likely to combine with change in another driver. So for example, multilateralism and economic convergence is equally likely as unilateralism and economic convergence. And the other one is that change in different drivers, in the same driver, has the same impact in sending and receiving countries. So we aim to relax these assumptions. And these are the questions that we were trying to answer in our study. And we did this by means of a survey, also an expert survey. So what we did is that we came up with 6 dimensions. So it connects to the presentation just before. We had not 5, but 6 dimensions. So we added dimension technology. And for each driver, so we came up with specific drivers for Europe and for sending countries, because we were looking at migration from the rest of the world to Europe. From what we call less developed countries to Europe. So excluding North America, Australia, Japan. And we have these 6 dimensions and drivers that are specific to Europe. For each driver, we had these futures. So the futures are really scenarios that are completely opposite. And then we had, for the same dimensions, we had the 6 drivers in less developed countries. So the last 3 about the drivers within economy, technology, and environment were just the same as in Europe, but we had different storylines. supporting each driver. And then we have slightly different ones concerning demography. So it's really about demographic transition, whereas it was about population aging in Europe. And then society and governance also were a bit different. And just to show, I will not show you all the narratives that we use to elicit responses from the experts, but this is just to give you an idea of what of the narratives that we used. So you see here the one about population aging, the two opposite futures within the driver demography in Europe. So we use these narratives, and we ask migration scholars to estimate the amount of change that they expect that they would create for the migration, the pressure to migrate from less developed countries, and the demand for migrants in Europe. Those were mostly scholars within our network and extended network, so people we knew quite well and less well. Most of them, we had some filter questions, or not filter, but questions about their background, and most of them were more familiar with the demographic and social drivers. And this was, well, 1 year ago, a bit more than 1 year ago, that we collected the data. So much before Ukraine, for example. So here are the results. So just to show you a bit better what we exactly did. So we presented the narratives, and then we asked the experts whether each narrative, whether they thought it would lead to a strong increase, moderate increase, a continuation, moderate increase, or strong increase in migration demand in Europe. And then we did the same for migration pressure in less developed countries. And here are the results for the demand for migrants in Europe. We converted the values or the answers that I just showed. We converted them to scale ranging from -2 to 2. So -2 is a strong decrease. And here are the averages. And the standard deviations between parentheses. So experts expected an acceleration of population aging to have the largest impact on the demand for migrants in Europe. Economic growth would lead to an increase. And on the other side of the future, so the opposite futures, less tolerance toward migrants would decrease the demand for migrants, according to our sample of experts. And yeah, so the stagnation of economic growth has a similar effect. Here are the effects for less developed countries, the pressure to migrate. Most importantly, change in political stability was expected to play a major role. Stalls in the demographic transition. And economic growth will play a role, climate change also a very large role. So these are the assessments for each individual driver, taken separately. Now, in the second part of the survey, we asked the experts to assess how each change in each driver will affect the other drivers. So we use this kind of matrix. We presented them with each change on the left that will cause a possible change in the other drivers. So the experts could choose between, for example, faster aging in Europe will increase tolerance in societies for immigrants, decrease it, or it will have no impact. These were the possible answers. And the colors do not appear that well here. It was a nice figure that I prepared. But I think the take-home message is that, okay, with the frames, I was intending to show where experts agree, where darker frames, black frames, show more agreement. Where there is no frame, there is no agreement whatsoever. So, and with the colors, I was intending to show the size of the impacts that I was showing in the first part, so the expected change in the number of migrants, or not the number of migrants, but the pressure to migrate and the demand for migrants. But yeah, take home, there is a lot of changes, a lot of scenarios for which experts, well, there's a bit of everything. So some changes experts agreed that they will have about their impact on other drivers. Other changes they kind of agreed, but not completely. And there was also a lot of them that they just didn't agree at all. So it really depends. So this is the, I just wanted to show an example with the impact of faster aging in Europe. According to the experts, it will lead to less cooperation, and there is average agreement concerning this one. And the previous assessment on the size of the impact was continuation of migration. This is the same for less developed countries. There is more color, but this is because there was more changes. So in a lot of cases, experts expected more changes. Thanks. Agreement is about the same as concerning the demand for migrants in Europe. And I have 2 minutes. So last part of results. We were wondering how to combine the individual assessments for each driver, if they happen on their own, and if we consider interactions between drivers. So for example, a stall in the demographic transition in less developed countries would have quite a big impact on the stability, according to the experts. Political stability, it will have an impact on the economy, and also quite a big impact on climate change. And if you combine this, so what does it look like? Well, here we have the sum of the effects that I just showed in the row. So indirect effect, that's the magenta dot. And if we combine the indirect and the direct effect, then we have here the size of the bar that gives that. So it's a really rough way to combine that, but that gives an idea. So according to our sample, a stall in the demographic transition could have a big impact on increasing the pressure to migrate from less developed countries, a direct impact, but could have a much larger indirect impact. And that's the case with other drivers, especially climate change at the bottom also. And those impacts are bigger in less developed countries. I guess I will just conclude. So it's one of the first studies to just quantify narratives on migration. And we did so by quantifying change in different drivers separately, unlike the previous study that I showed you. And these are, in a nutshell, our results that I just sum up here one more time, and I'm done. And just to finish, was just published our paper in Frontiers in Human Dynamics.
Thank you, Mikael. Are there any questions or comments? Yeah, Roman. Gonna just, sorry to make this room darker, but the screen is not cooperating. So go ahead.
Thank you, Mikael. I'm Roman Hoffman from IIASA. I found your presentation very, very interesting. I was just wondering if you gave experts the possibility to also basically say that they don't know some of these processes, or that they cannot attest to some of these processes that you were looking at. Because I think the line between like an expert and maybe a more informed citizen can be quite thin, especially if you look at a host of different topics like what you did. And so some maybe answers might be more reliable than others. And I was wondering if you had accounted in any way for that in your survey. Thank you.
Thanks for your question. It's a good point, and we didn't do that. We didn't have measures of certainty. It would have been good, yeah.
One back, and then yes, afterwards.
I have very interesting presentation. Maybe I missed you explaining it, but your title is about quantifying narratives, and I missed the step where how did you get from the expert survey to the quantification? So how did you attribute a number to each of these things? Thank you.
So we developed narratives based on previous literature, and then we just presented the experts with those narratives and asked them to quantify them directly. So it's the experts who quantify them. And what I was showing was just the averages among all experts. So we didn't do further data treatment.
I have just a question, a clarification, and a small other question. So what was your time horizon? Maybe I missed it in your presentation for eliciting this input. And the other question I just forgot. Sorry.
You can ask me after. No, it's true. I think I forgot to mention it. Sorry. It was so in the questionnaire we were referring to the period 2030-2050. So I guess looking back at it, I preparing the presentation, I had to look back at the questionnaire, and I was like, why did we choose a range instead of a specific year? I'm not sure, but I guess the experts probably thought, okay, so around 2040. In between now and 2000, anyway, we had a range 2030, 2050, yeah.
We'll take one last question in the back, and then transition to Lucas.
Okay, a suggestion and then a question. Perhaps you should choose a larger font size next time if you give presentations, because the results were hardly readable to me. With this caveat in mind, I was quite surprised to see relatively small standard deviations around your means, which suggests that experts have revealed also in your questionnaire well-known expert biases, systematic expert biases like overconfidence. And I wonder, what is your approach to mitigate against these well-known biases?
Well, yeah, I'm not sure if I would call the standard deviation small. I think it was because we only had 5 values on the scale. So, and like I said before, we didn't ask questions about how certain the experts felt about their responses. They already found it because reading all the narratives and then quantifying them, and then there was a part about assessing the impacts from change in drivers and the other drivers. That was quite a lot of burden for the respondents already, and they were complaining that was already too much. So it would have been too much to include more. Yeah, that's our contribution for this one.
Great. Thank you for your responses, Mikael. Lucas, come on up, and we'll keep moving in the program.
So let's skip that one. Yeah, I'm Lucas from the Potsdam Institute for Climate Impact Research, and I'll give you a brief introduction on the global migration model, bilateral flows, by place of birth, age, and education that we developed for a FUME project. A few words on motivation and introduction. It is an extension of an existing bilateral migration model that used place of birth, origin, destination that was introduced by Ricani and Schewe last year. The extension we do is we try to include age and skill-specific migration dynamics, because we found, partially in literature, partially in data, that, for example, different age groups have very different mobility if you compare very young people to older people, for example. And second, we also hope that capturing these dynamics will improve the original model. And the last point, what we are very keen to try, was to take that model and couple it to population projections, in our case, those done here at IIASA. A little heads up, it might be a little technical, just so that you know, I'm a theoretical physicist by training. So let's have a look at the model itself. we have two equations. We model emigration, transit migration with the top equation here, and return migration with the bottom equation. What goes into the model is, it is a gravity type model. So we have population stocks, but instead of destination population, we use relative diaspora as a polling factor. So these are our two demographic inputs. Other than that, we have economic inputs for emigration and transit migration. We have the origin GDP going into some function f that is shown on the bottom right, which is an overlay of migration incentive and migration resources. And other than that, we use the destination to origin wage ratio, which is skill specific for our model. And the last few letters here in our equation are fitting parameters. Basically, we have two linear scaling factors, AA and BA, which are age dependent. So using these parameters, we can basically force some kind of age distribution onto our model. And other than that, we have parameters for wage and relative diaspora to kind of vary their importance for the migration decision. I said we want to include age and skill. So we have three age groups, 0 to 24, 25 to 64, and 65 plus years, and two skill cohorts, high skill and low skill, where high skill is upper secondary education or higher, and low skill is everything below. So having set up this model, theoretically, there is a lot of input data that goes into it. Most of it is, oh, that's weird colors. Most of it is quite straightforward. There were some arrows at some point, but I think you can't see them because of the contrast. So relative diaspora, population, stocks, GDP, all of that is pretty straightforward. You can use UN population data, age and education attainment from the Wittgenstein Center, and GDP data. The very challenging part of it was to actually get skill-dependent wages. Because even though some countries do have wage data, they're definitely not harmonized, and if we choose one separation level for high and low skill workers, for example, this separation won't be the same for all the countries. So what we did is we created our own global set of skill estimates using age and education attainment data, average years of schooling, some Mincer regression coefficients that I'll explain in a bit, and GDP data. So taking a look at how we estimate these wages, we based our approach on that on a paper that Dokier published, I think, almost a decade ago. But the basic assumption is that the GDP of a country consists of, or is given by the wage for some skill times the labor force or people working in that skill cohort. For us, we have two parts of that, one for high skill, one for low skill. And rewriting that equation, we'll get the second expression here, which gives us the wage, but it's still depending on the wage ratio, that part here. Luckily, that wage ratio we estimated using Mincer regression. In this case, there's the Mincer earning function, which estimates wages based on W0, which is the baseline wage, years of schooling S, and years of experience X. If we look at the ratio between high and low skill wages on the right here, everything cancels out except for this coefficient rho I, which is country specific, how important education is for the actual wages, plus the difference in years of schooling between high and low skill workers. There goes, like at that point, there goes in quite a strong assumption because we put the difference in years of schooling to 9 years. We checked for different years in the overall results in the end. It didn't matter that much if we, for example, choose 7 or 11 years, and with 9 years, we kind of felt confident. So putting all of that in, we'll get this equation for estimating wages. Last point missing is this rho I. So this coefficient that's country specific, that's where we use the Mincer regression coefficients that I mentioned earlier. There's a database where those coefficients have been collected from publications all kinds of databases. So we looked, like, unfortunately, there was no coefficient for like every country. So what we did is we took those samples and tried to find a depending variable. We checked GDP per capita, which didn't really work that well. But average years of schooling, there we at least saw some trend. What we did is we took this two-part linear function for up to 12 years of average years of schooling. We can see a decreasing coefficient row with increasing average years of schooling, and after 12 years we keep this coefficient constant. We also used different points on where we make this transition again. They don't have such major impact on the results, but for 12 years we got the best estimates in the end. So having done all of that, we actually were able to have now a global set of wages depending on skill level. And the last part of like setting up the model now was to calibrate all these tweakable parameters. Unfortunately, we couldn't just take bilateral flows to estimate all the parameters because we have this AA and BA coefficients, which are age dependent. So we need some kind of age distribution, like how much do people move in some age group. So we're lucky enough to have age-dependent immigration data, which was estimated using the same method as the bilateral flow estimates by Guy Abel. And what we did is we took a very simplified version of that model, only considering diaspora as a pulling factor and the population stocks and these coefficients to get some kind of a relation, how much, like, or how, yeah, how does one age group move compared to another? So what we didn't take the total values estimating them, but what we got out of that was saying, okay, younger people move, for example, 2 times as much as older people, and having those relations, we moved on to the second step. It actually used bilateral flow estimates, the one from Guy Abel, and estimated one of those age parameters, which then determines the others as well as the wage coefficient and the diaspora coefficient. Just to briefly go through the results, the parameters on the right-hand side are mostly in accordance with what we find in literature. We see that the age cohort from 25 to 64 years moves or is the most mobile. Slightly behind is like A1 is the youngest cohort, A2 the intermediate one, and A3 is the older cohort. Younger people move slightly less, and when it comes to wage and diaspora data, we also find coefficients that are in accordance with, for example, Dokier's approach, or for the diaspora, other papers that we found on that. Looking at the overall results now to check if it makes sense to use this model for our projections, we compared it with the original model, comparing it to age, immigration data, and bilateral flows using R squared and Sørensen dice coefficient. And we can see that OG is the original model, AE is the age education model, and we can see that especially for age immigration data we see major improvements, and for the bilateral flows we see minor improvements, but still good enough to keep on going with that model in what we thought about it. So last slide, yeah, lovely, I hope you can read that. So the whole point of developing this model was now to couple it with the population projections done here at IIASA. Because for our model, we previously had some population projections, but they were rather simple, and looking at the population projections, which also include migration here, there were those migration assumptions were very simple. So what we then did is the population projections does their fertility, mortality, stuff, and then feeds into our migration model. There is a reduction in cohorts because we weren't able to use all the, for example, 21 age cohorts that IIASA uses. But calculating the migration flows, they then feed back into the population projection. And that's also in this setup where the scenarios get important, because now we can use different demographic scenarios, for example, the standard high-low fertility things, to play around with different population dynamics, demographic dynamics. And for our model, we can, for example, use different GDP scenarios to impact the migration incentive or the wages. We are at the point where we just set up the model. We have some not really trustworthy preliminary results, but we are hoping to get there soon, and hopefully by next time you can actually see output of that model. So that's it. Thanks.
Thank you, Lucas, for keeping to time. If there are questions, Ellen, we'll take them now.
Yeah, thank you, Lucas. This was really great. One of my questions was something you answered at the end. I was wondering whether you were aware that the migration part was quantified in the SSPs, and whether you have, what you're doing basically is replacing the migration quantification in the SSPs.
Yes, for our model, we're doing exactly that.
Yeah. Once you run the whole thing, it'd be great to see the difference in quantification between the two.
One of the first comparisons we're actually doing right now is, for example, taking the, I think UN has some like net migration data, so we're looking at like how much does our model diverge from those net migration estimates that were done.
Great. I have a couple clarification questions. I guess I didn't catch, so I'm going to list everything and then you can answer what you want. I didn't catch, you mentioned you were using the bilateral data by Guy Abel and others. I didn't catch where the age data came from for the migrants.
The age data is also estimates by Guy Abel that are just not published yet. We're just lucky enough to get them.
Okay. I was wondering, because you showed the gravity equation in a non-log form, I was wondering whether you use any sort of fixed effects in the thing?
No.
Okay. So I'm almost done. And then a couple remarks. I was surprised by what you said, that you found that younger people moved less. I would have assumed it would have been the other. And let me just say the last one and then I'll be done. So basically what you assume with the skill when people move is that someone with a high skill level would move to another place and immediately be considered a high skill, even if they move to a place that has higher income. So you have to make those kinds of assumptions. I'm wondering if you have a way to quantify that bias that might occur if people actually don't end up being able to do the job that corresponds to their skill level.
Yes. So, okay, let me answer the last question first. So we don't have any assimilation in our model, as you said, but I think one way we could handle that, as I know IIASA has education transitions in their population projections, so that's something we can use to kind of account for that. What was the gravity? What was the question before?
Youth.
Exactly.
Young people migrate less.
Yeah, you're right about that. The point here is if you look at the distribution of people moving, the peak is, as we found, usually between like 20 and 30. Our cut is at 25. So that's, and if you take a look at the coefficients, they're quite close. It's not that much of a difference, but you're right. Like the major population or like the biggest part of people move are like between 20 and 30.
Thank you.
There's a hand up in the back with Lei-Wen.
Lei-Wen Jiang. Lucas, I really like what you have been doing. And I wish to learn more from you. And yes, I have right now 2 questions for you. First, so compared to what have been done with the age gender profile for migration by Andrew Rogers, and there are some differences, right? You consider the age group, for instance, one age category up to 25, you said, but we know that the migrants before 25 has a very different age pattern, right? And it was rather high in a very young age, then declined to very low in school year, and after school year, maybe the increase, right? So you don't consider that at all as accompanying migrants, right? Accompanying children, and parents. That's one question, right? For the age pattern. or what do you see the differences? Right now you have like 8 parameters in your model compared to Andrew Rogers' 12 or 9 parameters, and what's the advantage or disadvantage? And second, this is dealing with the international migration. International migration, you put those individual characteristics as a very important parameter and predictors, right? But for international migration, mostly you can see where people move just because the average market, right? That income in the one country higher than the other. That's the main differences, right? That's the gravity. I don't know what the differences are. Education definitely important, but the differences, the disparity in income, will that be even more important? Thank you.
So for the first part, if we, for example, account for like very young people, I think that was one point that you made, right? That the differentiation, like that they're coupled to. Okay, let me phrase it that way. So what we did with like this different migration behavior for example, younger people, we stumbled across a problem that, for example, very young people don't have any educational attainment, right? So in order to kind of get rid of that problem and couple, for example, children to their parents, we assigned educational attainment from the 25 to 64 years cohort to those ratios we assigned to the below 15-year-olds in order, like assuming that they'll move as their parents will. That was like one thing that we did there. Not entirely sure if that answers your question. The other point was that GDP is the major driving factor, right? Or like economical factors. We agree on that. The previous model actually only used GDPs. They had like this input function and the pull factor was the destination GDP. The major point of including age and skill was that that was kind of necessary to couple it to the population projection model, because if they don't have any like age dependence or skill dependence, it'll be very hard to attribute them to like different age and skill groups in the population. So that was the main motivation to actually create such a model. Not like obviously because it'll get a bit better, but we're also using more parameters than the original model. But the main incentive was to use it coupled with the population projections. And another point on this different age groups, that they have different behaviors, that first of all, unfortunately, I'm not so familiar, since my background is rather very technical, about all this dynamics. One important factor why we choose those groups is because we kind of had to pay attention that they're in like similar size, because otherwise you have sometimes very small population groups, and having such a rather simple, like let's call it rough model, you're in danger of, for example, depleting population stocks, etc. So you kind of have to balance all the age groups to not deplete any of them.
Great. Thank you, Lucas. Next presenter, I've actually lost track, is Roman. I will say that in the Scaling Fences report, which you can go ahead up, Roman, in the UNDP report, is that this is about Africans coming to Europe, basically, and they interview them, and often they have higher skills and higher education than you might expect in sort of this layperson sense. So, Roman, take it away, and we look forward to hearing your presentation.
Yeah, good morning, everyone, and thank you very much for having us present our work here in this session. I'm going to talk about an ongoing project of ours on the links between climate change, aridity, and internal migration. And we're using a novel data set that we have compiled from IPUM's international census data on internal migration flows. In a way, our project is very similar to what Lucas has presented before, so thank you also for the introduction, to gravity models, for example. So we're also looking in bilateral migration flows. Unlike what Lucas has done, we look not at international migration, but really at migration within the borders of countries, and looking at migration basically at the subnational level between different regions. This is joint work with Guy Abel, who you have also heard before the name, Raya Mutarak, Maurizio Malpede, and Marco Percoco. And as I said, all of this work is still ongoing, so we are currently working on the historical, empirical analysis. We also plan to look into doing some scenarios, but generally we think that this, the insights from this work can be very informative also generally for scenario building efforts in the future. So generally we see that in many regions of the world, changes in environmental and climatic conditions are linked to migration dynamics and human mobility more broadly. However, the strength and the direction of the relationship very much depends on local conditions and the type and intensity of the experienced environmental influences. And there's a need for more comparative studies, especially on internal migration, that would allow to compare mobility patterns in different regions across the world. And with our study, we want to basically add to this and want to help filling this gap by estimating the impact of changes in aridity and desertification processes on internal migration flows worldwide, using a novel data source on bilateral internal migration flows from a total of 72 countries, and the data is based on harmonized IPUMS international census data. And what is nice is that the data does not only allow us to study whether there is a relationship between changes in environmental conditions and mobility, but also to explore some of the mechanisms and, as I said, differences across contexts to understand who migrates, under which conditions, and also to which locations. Our approach is very closely related to another study by Garcia et al. That was published in Migration Studies that has modeled internal migration flows in sub-Saharan Africa also using the IPUMS international census data. Already today we see that large parts of the world are characterized by aridity and high temperatures and spatial rainfall variability. Drylands today comprise already more than 40% of the global terrestrial area and are home to around 3 billion people, or 1/3 of the global population. Under climate change, these areas are expected to grow in size, so the topic of looking into increases in aridity are very, very important for many parts of the world. Here in this study, we want to link basically changes in aridity as our environmental driver with migration data, which we derive from IPUMS International as our primary data source. For those of you who are not familiar with that data, IPUMS collects census data from all over the world, harmonizes it, and makes it available to users. As of today, there is data on more than 100 countries worldwide available, and we use data from 72 countries where we have information on migration histories. To construct our migration outcome, we use on one side the information on the subnational region of residence of the census respondents and couple this information with the census information about which region the respondents lived in 1 or 5 years ago. And based on these two pieces of information, we can basically determine how many people have moved from one region A to another region B and vice versa in the past 1 to 5 years. And this is really the basis of our migration flow estimates that we will be using in our estimation. The unit of analysis that we would be considering then is the GEO1 census regions over time. So we're not looking at households or individuals, but we look at regions and migration flows between regions, considering basically bilateral flows between them. As climate data, we use information on changes in aridity from different climate data sources, and I will talk more about those in a moment. To give you an illustration of the data scope that we have, so as I said, we have data on 72 countries, which were derived from a total of 201 censuses over time, covering a total of 1,454 GEO1 census regions all over the world. This is the boundaries, the shapes that you can see here in this map, highlighted in light blue. And our data covers a time series from 1960 to 2016 for some countries. For other countries, we have shorter time intervals, but for some countries, we really have a very broad time period. And in total, based on this data, we can calculate 140,480 bilateral flows between the regions within the countries. To give you an illustration here for the example of China, so here you see migration flows between different regions. So we basically calculated or estimated migration flows between one region A to another region B and vice versa, and then also have information on migration flows from another region C to region D and vice versa. And this for basically all the countries and regions in our data set. based on this, we calculate the annual outmigration rate from one region A to another region B, and couple it with different measures for aridification and changes in aridity. Here we use different measures to test basically whether our results are robust also to different specifications in the climate data. We work here with the aridity index, the SPI, both over a 3-month period and over a 12-month period, and the normalized density vegetation index. So all of these capturing basically changes in aridity and drought conditions in an area. And then we add a few controls in our models. But basically our models are relatively parsimonious. So we regress the outmigration rate on the changes in environmental conditions, adding also fixed effects, both origin and destination area fixed effects, as well as time period fixed effects. And then we estimate that model with Poisson fixed effects estimation, or PPML. Here is the main baseline results of our models, where we estimated the outmigration rate on the different climate indicators that I've shown you, which you can see here. I don't know if this pointer, which you can see basically here to the left. This is the different climatic indicators, and then you have the coefficients displayed in the different columns of the table. And just to mention that, because I forgot, you see all the relationship coefficients are negative. That is because all the aridity measures that we have, they are negatively scaled. So smaller values mean drier conditions. So if we see a negative coefficient here, that means increases in migration. So that is important to be kept in mind throughout the presentation, also for the other results. And what you see here across all measures are significant and sizable effects over time on outmigration, with an increase in aridity in the different regions. We see that, for example, one standard deviation increase in aridity index in a region leads to a 4.4 percentage point increase in the outmigration rate on average. So these are quite sizable effects, we think. We have then looked into differences between different regions and also between different characteristics of those regions, classifying them by their baseline level of aridity. And here we see interesting patterns. We see that our results show up most consistently on one side for Africa and the Middle East, but then also, but a little bit less consistent for North America and Asia and Pacific, whereas for the regions of Europe and Central Asia and Latin America and Caribbean, the results are less consistent according to our estimates. The NDVI is a little bit of a measure that does not show so consistent results compared to the other measures. So we are also considering now if we want to keep it in, and would be happy to hear also your opinions on that. If we distinguish by different baseline levels of aridity, we see on one side that the effects are strongest on migration in areas that are already hyper-arid and arid as of the baseline year. And also in areas, and that was interesting for us, that are characterized more by a subhumid and humid climate. But we don't see so much going on in the semi-arid areas. But definitely the strongest effects are found in those areas that are already characterized by arid and dry conditions. We have then combined these insights in a new model where we basically added both the world region and the baseline level of aridity, and have tried to come up with some careful predictions. And what you see here is basically the plotted marginal effects, the plotted relationship coefficients that I have shown you before on the x-axis, and countries and regions in darker red. They are expected to have a stronger migration response to aridity, changes in aridity, whereas in blue there's a less strong response. This does not yet take into account the actual changes in aridity. It's just a plotting of basically what we would expect if there was a change of one standard deviation. And what you can see is that we would expect the strongest effects on migration in areas in sub-Saharan Africa, but also in parts of Latin America and the Caribbean, and then in South and Southeast Asia. Apologies, also here the coloring scheme is a little bit blurred. And finally, and this is also still preliminary analysis that we did, we have looked into characteristics of the migrants, very similar to what Lucas has presented before. So with our data, we could not only distinguish how large the flows were from one region to another, but we could also see the flows different for different age categories, different age by sex, and different education categories. And what we see is then that the effects, the impacts of changes in aridity are strongest on the lower educated groups. So we see that they seem to respond stronger to the changes, as one would expect based on the previous literature. But then we see a little bit of a slightly U-shaped age pattern, in a way that we see a stronger response in mobility among the youth and very young population groups. And we're still looking into this and trying to explore this a little bit more. We have some explanation, and happy to discuss those later on in the Q&A, why we might find these patterns. As I just have one slide left, I may give you at least some insights on what our thoughts are. I mean, we have a very unique migration measure here as well. So often when we look at internal migration, what the previous literature has looked at is often whether household members are absent. It's survey data looking into absenteeism in households. So here we have really realized migration flows of people. So it's really an ex post measure of migration. And we are thinking that this may produce different results than what previous studies have found that may have looked more at, let's say, the origin region perspective and asking about who in the household is absent. And this by itself is, I think, an interesting insight to at least think about more how these different ways of collecting data may influence our results. To conclude, we have conducted a study on the impacts of changes in aridity using a novel global data set on bilateral internal migration flows. Our findings indicate very meaningful migration impacts, but also considerable differences across regions depending on environmental and socioeconomic conditions. And these are very important to be taken into account. Of course, it's important to emphasize that our study also faces different limitations, for example, related to the measurement of the migration outcome, but still we believe it adds important insights and also maybe some of the needed comparative evidence that allows understanding some of these underlying mechanisms and influences of contextual factors more in this field. And with this, I would like to stop and thank you very much for your attention.
Thanks, Roman. I'll take the gentleman in the blue shirt here first, and then Carolina and Helen.
Yeah, thank you very much for your presentation. I had two questions basically, but the first one you kind of answered. It was about the NDVI. My second one may be a little bit naive or very naive. I don't know. In some places migration, is temporary, seasonal, or lifestyle basically, nomadic lives, or in small island nations where they switch between islands. And how does this affect your results or your outcomes?
Yeah, thank you very much. That's a very good question, actually. So we have a quite broad migration measure. So our migration measure looks basically at, in most cases, at like 5-year intervals. So counts people that have moved from one region to the other, realized moves from one region to the other within the last 5 years, which we then couple with environmental data in what occurred in these origin regions in the past five years. So it's quite a coarse measure that may very well miss, let's say, some of the mobility patterns that we see when it comes to environmental change processes, like changes in seasonal mobility, also something that was discussed in the first presentation. But what we would really have here is realized migration, basically as measured in the censuses, which is a different measure than other studies have used, but I think still a very powerful measure to consider here. Thanks.
Carolina and then Helen.
Thank you very much for your presentation. I always double appreciate when I understand it. And but I have like context-related couple of questions. I'm not sure, but I see that Morocco and Tunisia are included in your sample.
Right.
And you said that you are looking for 5-year periods, and actually precisely in those countries, censuses are made each 10 years.
Right.
Then you have another issue that most of migration, like maybe not, but preliminary migration, even related with environment, are within the region. Mm-hmm. Then is the third issue that, for instance, in Morocco in 2009, if I remember correctly, there was division of regions, because I understand that you're looking like for this, like in Poland it's voivodeship, so in there are different names, so these big country regions. Mm-hmm. So there was division, so it may also influence your data. Mm-hmm. And then the final issue, you have not included gender aspect as well, which is very much significant because women quite often are left behind or like decide to stay somehow. And like following a little bit this question, yeah, because I was doing like also kind of census among people like on the local level, and the question about migration, who is actually migrant, was the one that we were struggling most, because whom we should actually include, whether those who are moving for 3 months, then came back for 3 months, and then moving, someone who actually moved with all his household, or whether someone is living in Spain or Morocco and coming back just for 1 month each year because he built his house for retirement in a valley. So like, that's so contextually fragile, actually, to make such assumption. Yeah.
Yeah, no, thank you very much for raising these points, and all limitations that you highlighted, they are there. And we cannot deny that. I mean, censuses are collected every 10 years. Intra-regional flows we cannot capture because we only have this in-between region information and so on. And also what you said, of course, like the definition of like a migrant and so on. So we have a very specific one which we transparently communicate. Still, this data set is really one of the few that you would find that allow you to do at this large scale, these comparative analysis. We suffer under like scarcity of data on migration, in particular when it comes to internal migration and actual realized moves. And despite all the limitations we have, we still think it's important to have this kind of data and also to make it basically useful for the community to look into these general patterns while keeping exactly the limitations that you mentioned in mind in the analysis.
One last question.
Okay.
Who's aware that she's cutting into her own time.
Yeah, sorry.
How generous of me. Just a couple
clarification
questions, actually. I guess, how do you deal with because you don't really know the timing of the migration event, I guess, if you have 5 years, so how do you attribute the climate stuff to that? And then I'm not super familiar with the aridity indexes. Can you just explain very briefly the difference between the three? And the last point, and then I'm really putting myself down, is I think there is international migration data in IPAMS. So I was wondering whether you were considering using it or not.
So yeah, thank you. So starting from the first question, so yeah, we have some inaccuracy, of course, when we link basically the environmental data. You're right, we have only the information how many people have moved within the last 5 years. And so we basically try different specifications where we, for example, link in our baseline specification what has happened in the origin areas in the last 5 years in terms of changes in environmental conditions to these migration outcomes. We try also like wider time windows, but of course there is some inaccuracy inherent in this. About the second question, I think it was about the different indices, yeah. So very briefly, like NDVI is remote sensing based, measuring the greenness of an area. The SPI is a water balance indicator, capturing basically like the relationship between rainfall or like rainfall amount and the evaporation. And the aridity index is also very closely linked to what the SPI does, but looking into yeah, I think another combination of basically rainfall and temperature, but they all are composite indicators measuring really both the rainfall side as well as evaporation. And the last question, sorry, I missed that. We have thought about this, so we want to start for the beginning with finishing the internal one, but we have thought of possible ways to linking it to the international migration as well, using those measures more, because also there could be interesting insights generated from that, as we know, and also has been shown before, international migration moves can be linked in these processes, could be interesting to explore together.
Great. I'm sorry we can't take more questions right now, but Fabienne, please follow up with Roman offline. And we'll next have Hélène present on her work. Thank you.
Thank you, everyone.
Thanks, everybody. My name is Hélène Benveniste. I'm currently a postdoc at Harvard. Actually, the work I'm presenting today, I started doing here. I spent the summer here 3 years ago. So this is joint work with Raya, who is here, and who is a co-author on half the session, I think, and Jesus Crespo-Quaresma and Matt Caden. So, okay. Am I pushing on the green button? Is that how it works? Great. So this project was about tracing the effect of international migration on the SSPs. And the point, I'm going to go quickly on the point, we've been discussing the effects of climate change, potentially on migration, that can happen both directly and indirectly. This project really focused on 3 key interactions. The first one, the fact that migration is already used as an adaptation strategy to climate change impacts. Another one is an important one, which is the fact that the remittances, so the money transfers that are sent back by migrants to origin communities, can really increase the adaptive capacity at origin for people who stayed behind. And the last point, which is a pretty obvious one, which is that migration and economic development strongly influence each other. So we've seen historical, like kind of empirical case studies, just Roman presented one. A big chunk of the literature on climate migration is also now focusing, as Alex was saying, on projections, exercises of migration in the context of climate change. Typically, those projection exercises can use very different types of models. For instance, integrated assessment models, but not only. This is kind of a stylized representation of an IAM. What's important here, the point I'm trying to make is that for those types of projection exercises, often scenarios are necessary because they're used as input in many of those models. However, when you start wanting to do projection exercises of migration specifically, you can't use any type of scenario. What we're gonna need are scenarios where the effect of migration is explicit in them so that you don't mix up everything in the process. So this is really where the SSP is coming to play. We've seen this graph a zillion times before in the past 3 days. We're aware now that the 5 qualitative narratives of the SSPs have embedded assumptions on international migration. Those assumptions are quantified pretty roughly, as Lucas was saying, in the population projections, but they're entirely implicit in the other components of the SSPs. Population is just used as input, but the migration aspect is entirely hidden in the other components. So GDP, energy consumption, greenhouse gas emissions, inequality, etc. And so this project was basically about making the effect of international migration explicit in those scenarios. And it was published last year in Climatic Change. Feel free to check it out if you want more details on it. So what we mean by saying we made the effect of international migration explicit is that we developed versions of the SSPs for an assumption of 0 international migration. So typically people start by saying, oh God, 0 international migration, it's not possible. Those are not meant to be realistic. What those projections are meant to do are 2 things. First, they are meant to be able to highlight the effect of international migration by comparing them to the original versions of the SSPs where migration is hidden. So it's a comparative exercise. And second, it's a very practical standpoint, which is that those 0 migration projections can then be used as input to modeling exercises where migration is explicit in the model, but not in the scenario. So it's exactly the same mindset of the discussion that we've been having this whole 3 days of SSPs not having climate impacts in them so that they can be used for climate impact studies down the line. So this is the same spirit. These versions are not going to have migration so that they can be used for migration studies down the line. So the way we did it, the population projections were not done by us. I don't think that Samir is in the room, but Samir Casey, who is the one who did the original population projections, was kind enough to rerun his model where he implemented an assumption on 0 international migration, and that's the data we got. Then the bulk of the project was really around the income projections. For us, what we did was that we removed 2 effects of migration on income here. One, the effect of changes in population sizes, and second, the effect of remittances. So to model remittances, you need to model bilateral migration flows because you need to figure out where the money goes, basically. And so for that, we used a gravity model pretty similar to the ones that have been presented before. So where we take into account GDP at origin and destination and proximity measures between origin and destination in terms of distance, in terms of common official language and whatnot. And then we were able to retrace the migration flows and associate with that the remittance flows. And then we removed that from the income projections. We also did versions of 0 migration for the SSP projections on within country inequality. That was work done by Narasimha Rao and others, mainly in the energy group at IIASA. Basically what we did is that they did an empirical analysis where they had a bunch of drivers of inequality, and we computed the changes due to migration only on the education drivers of inequality, which is where we had data. So we used their coefficients, basically. And finally, very simply, I'm not going to get too much into it here, but we were able to develop projections for energy consumption and CO2 emissions for zero migration. The course assumption we had to make, and we discussed it with a few people earlier this week, was that we assumed that the effect of migration on those quantities was only through the income channel, and not like for a given number of people and income level, the migration question did not affect the energy consumption or greenhouse gas emissions. So I'm going to mainly present results here on GDP and inequality. So the bulk, again, of the thing was the gravity model. So this is the estimation in terms of data for the bilateral migrant flows, the dependent variables. We used Gaia-Abel's data, just like everybody in the room. So those flows are derived from bilateral migrant stock estimates that are available from the World Bank. You actually can derive stocks from flows from stocks, in different methods. So we tried different methods here. The two columns are showing that. We find pretty standard results in terms of the direction and the size of the effect of all those drivers on migration flows. So a positive effect of population sizes at origin and destination, positive effects of GDP levels, but stronger effects of GDP levels at destination, negative effects of distance, etc. Let me show you results briefly. This is first the effect of international migration on income. I hope you can see on the left-hand side what I'm showing are the world income per capita projections over the century. So it's average world income per capita, very coarse. The color code is the 5 different SSPs. And then you have 2 different curves on the left-hand side. The circles are the original projections where there is migration, and the triangles are the ones that we develop where there isn't migration. For clarity, on the right-hand side, you see the relative change between the two. What you can see basically is that in all of the SSP narratives, what we find is that international migration on average tends to make the world richer, which is not necessarily something we expected to find in all the SSP narratives. So it was an interesting result for us. Of course, when you do that at the country level, you see much more heterogeneity in the results. The effect, of course, depends on the country, but it also very much depends on the SSP narrative. And in particular, the destination, the exact migration and remittance corridors are going to change depending on the SSP narrative. Then if you look at the effect of international migration on inequality, first what you can do is compute inequality between countries. So just looking at average income level for a given country and compare that across. We used the Gini coefficient. I'm sure many of you are familiar with it. It's basically a measure of inequality. 1 means very unequal, 0 means very equal. You have on the left-hand side the 2 projections with and without migration, and on the right-hand side the difference between the 2. Here again, what we found was that international migration, on average, tends to make the world more equal. It tends to reduce inequality between countries. It's very mechanistic. It's because when you have migration, in that implementation, you have remittances, and that tends to reduce inequality across countries. As I mentioned, we also looked at inequality within country using the work by Narasimha and others. What we found there was that international migration tends to have little effect in most origin countries, and it tends to reduce inequality in most destination countries, mainly because with the data we used here, international migrants tends to be more highly educated. So just to wrap up quickly, I don't know where I'm at on time, but the first point I want to make is on the substance of it. What we found was that migration tends to make the world, on average, both richer and more equal in all of the SSP narratives. Now, you see a whole lot of heterogeneity at the country level when you look at those results, which is why, as Carolina was mentioning earlier, we really do think that using a scenario approach is very helpful in order to tease that out, even if you can't assess a specific probability to each scenario. Now, from a practical standpoint, we designed those projections so that they stay consistent with the SSPs, so everything is rescaled so that you match the population projections of the SSPs. again, they were designed so that they can be used as input of migration models, of models where migration is made explicit. I have a couple papers that use this method that are published or about to, so you can check that out. We hope that with this method, we have been able to contribute to all those efforts that aim to endogenize population dynamics in all kinds of models, including IAMs. A flag for kind of policy relevance here. Those types of approaches, I think, are really helpful to study interactions between different types of policies that are not often considered together. I'm showing the 2 SDGs here, 13, which is climate, and 10, which includes actually both migration and inequality. And the last point is that those were made available in the IPCC database, scenario database of AR6. It's largely emission scenarios, that database. It's hosted by IIASA, but those scenarios without migration are available there as well. And yeah, with that, I'm happy to take questions. These are the references of the paper. Thank you.
Great, thanks, Hélène, and thank you for keeping to time. I'm sure there's some questions in the audience on this work. Yes, one in the back.
Hi, thank you, Helena. This is a really, really interesting presentation. I was wondering, because you looked at the inequality variables related to migration, I was wondering if you've had a chance to dig into the emissions and vulnerabilities that come together with migration.
Yeah, so I guess you can look at that in different ways, specifically looking strictly at the SSPs, the emission projections of the SSPs. What we found, if I'm not mistaken, is that migration has not a huge effect on emissions, but mainly we didn't have like a very deep dive look on what it meant for emissions specifically, because the aim again was to use all those projections as input in modeling exercises. When you do those modeling exercises, what you find is that international migration overall, with the assumptions we made, did not play a huge role on overall global emissions. They play a little bit of a role on the distribution of emissions. If down the line what you care is climate change and global mean average temperature increase, it basically doesn't show anything really. And that's again to keep in mind that international migration flows, although tend to be very prominent in the public discourse, it's not such huge numbers if you look at like the population, the global population size. You're talking about 1 or 2%. It's not big, so when you look at global emissions and temperature increase, it's really within the margin of error. Yeah.
I think the second part of the question was about vulnerability, though, right? Was that correct? Or so I'm wondering whether the
that you're right. Actually, on the vulnerability point, then international migration starts to matter a lot. Not so much in terms of total numbers, but what you see if you start comparing the situation of people who move versus that don't, who have the option to move versus not to move, you start seeing really very big differences in vulnerability. If you look at vulnerability as a measure of how much people are affected by climate change and how well equipped they are to deal with it, basically. Then you start seeing a very big effect with international migration being an important way through which people increase or decrease their vulnerability, increase their resiliency, both by either moving and or by increasing the resources that are available for them to deal with the effects wherever they are, whether they have moved or not.
Yeah, there was another hand in the back. I don't know if...
Thank you for the very interesting presentation. I have just a curiosity. You said that with migration you have less inequalities, let's say, and this depends on the remittances, you say, but you consider also, I don't know, other economic mechanisms like, I don't know, wages equalization across countries.
Yeah, so this is again kind of a coarse analysis in the sense that the two things that showed an effect here were changes in population size and remittances. And if you look at that, they kind of counteract one another. The change in population size is going to act in one way, the remittances sometimes in another way. But you're right that we didn't do a very fine analysis on, I don't know, the distribution of labor in whichever sector people might work in. The type of model we used to do that was not was not detailed enough to get into those mechanisms. But there is a huge literature on migration that really looks at that in more detail.
So we are slightly over time. I'm going to allow one more question. Did you have your hand up? Okay, just one last question, and then I think we'll go to the break. Thank you.
Thank you for the very nice presentation. I have one question. Your results seem to be very robust across scenarios, but they are very close to the original outputs, as you pointed out, so the deviations are very small. So let's say if the uncertainty in your outputs exceeds this kind of small level, have you checked the sensitivity of your modeling outputs? And
yeah, so I'm not sure I understand your question fully. It's true that I think the point you're saying is once you remove migration, it doesn't change the overall results that much.
Exactly.
And so if you do the modeling exercise down the line, maybe it doesn't matter so much. And you're right, it doesn't matter so much. I do think that from, I guess, an intellectual or like a principled perspective, it's important to have a very clear sense of what you're putting in the model as input versus coded clearly as part of the model. I feel that that's a conversation that has been ongoing here about what do you put in the scenarios versus what do you put with what you do with the scenarios. And so I guess this whole project was about trying to be very consistent and very transparent about what is in the beginning versus what is in the end, if that makes sense. But you're right that on this question specifically, it didn't make a huge difference in terms of numbers.
Okay, with that, I think we'll take our pause café, as they say in French. And so there's coffee around the corner. We do encourage you to stay for the second part of our session. It starts precisely at, 11? Okay, great. So thank you for all the presenters. And Helen.
Okay, I guess that's our signal to start, 11 o'clock. Thanks to the Catholic Church for that. So we have the second half of our session on migration. As Alex said, we've joined forces. My name is Carsten Kessler. I'm the coordinator of the Future Migration Scenarios for Europe project that the first 3 presentations in the last session came from. So if you have any questions about that, talk to me during lunch. So in the second half, we have 5 more talks. We'll do the same rules as in the first round. So 12 minutes for the presentation. I'll give you the yellow card after 10, and then when you see the red card, you should really be wrapping up. Alex is here, obviously. Then we have Fabien, just to quickly check whether all the presenters are here. Lars is online, he couldn't travel. Gabriele is there, and Lena. Okay. Okay, she has some time to come back. So let's get started with Alex's talk then.
Okay, well, thank you very much for that introduction, and we'll bring up the slides. This is a collaboration between the Columbia Climate School and my colleagues at the CUNY Institute for Demographic Research, Brian Jones, who did the modeling work, and Jakob Schewe at PIC. Next slide, please. I feel like Mark Twain, and he wrote a letter once that said, oh, I have to do it myself. So Mark Twain wrote to a friend saying, I didn't have time to write you a short letter, so this is a bit that I have too many slides, and I'm going to go very quickly through the methods to kind of get to some of my main points about how clients are using some of these data in different ways for their own analyses. So this is a series of reports. Most of you probably heard about groundswell. We then produce 2 lesser-known reports at the bottom, Groundswell Africa, West Africa, and Lake Victoria Basin, and we're now working on an initiative which will be published this year called Africa Climate Mobility Initiative. The focus of this work is using gridded population data, which is one of our specialties at our center called Season, the Climate School, to project future population distribution using a gravity model. The basis was a conversation I had with Brian Jones in 2016, in which he was publishing this work, and I said, hey, wouldn't it be interesting to take this work and actually, instead of just assuming no climate impacts, actually look at what the potential impact of climate change is on population distributions in the future. And the opportunity arose when I went to a World Bank NOMAD meeting to discuss some work we had done for the Foresight project on past migration to actually take this further. So We actually got the funding, and we're under a very tight timeline to produce results. That's a different story. But basically, the gravity model, which Lena Raymond spoke about in another session, takes the existing population distribution at the top in the first time step, applies a potential or a place attractiveness based, generally speaking, on population density as a proxy for things like jobs, schools, services that make urban areas more attractive. And then you end up with another population distribution in the next time step. For groundswell, it's in 10-year time increments. For the other modeling work we've done, it's in 5-year increments. But what we wanted to do was insert climate impacts as something that affects the relative attractiveness of place based on water availability, crop production, flood risk, sea level rise, and conflicts. And that combination of factors depended on which modeling effort we referred to. So here we see essentially the world in grids. On the right-hand side, you see essentially 15-kilometer grid cells. This is a hypothetical island nation of 45 kilometers by 45 kilometers. And you project the population forward just based on the development scenario, and then you do it with RCPs, or the climate impacts, and you see that more people are moving to the southeast of that country, less people live in this northwest, and as a result, you get this kind of change in population, which we then attribute to migration. It's a very simplistic approach, and of course, can someone shut that shade? Could you just shut the shade? Because I found that this projector really washes the colors out. So what you see in the upper left is Senegal, which you can't really see, but the red cells are positive migration areas or in-migration areas, and the blue areas are out-migration areas. And if you summarize those at a country level based on different combinations of SSPs and RCPs, you get changes in internal migration based on climate impacts. The model takes, this is, the basic model is in the upper left. That doesn't really work because then you're gonna, it's, so the basic model's in the upper left. It goes through various iterations and in these time steps I mentioned, doing it on urban and rural basis. The local characteristics are what we were influencing with the climate impacts on water and crop production, and sea level rise is basically a mask. So you can apply a mask. We also did that for flood risk later, where you basically say the potential in a particular grid cell is reduced to attract new migrants because of flood risk or sea level rise. And then you can essentially come out the end of the projection model and compare both SSP only and RCP plus SSP projections of the future. This is the downscaling model. I'm just going to focus on the local characteristics for now, which is a weight on the potential indicative of the local impact of climate variables, as I mentioned earlier. And we calibrate the model. Actually, we're about to produce a publication that talks much more about the calibration, but we take 2 time steps, 1990 to 2000 and 2000 to 2010, which are what we consider to be observed changes in population. We pick the countries with the very best population data. In Africa, for instance, it's not always very easy to get good population data. And we look at the difference between the observed population change between those increments and the modeled population change, which is the gravity model applied to 1990 and 2000. And basically, the deviation then is explained in part by these variables, these climate variables. On the original groundswell work, we used certain assumptions and used a certain approach. The text is too small, but basically, we added some things in the later work that included rural-urban population density maximums that you could not exceed, ecosystem impacts instead of just crop and water impacts. So in other words, net primary productivity models, flood risk, conflict areas. We changed the SSPs around. We added a 4th scenario for optimistic. Instead of using decadal increments, as I mentioned, we went to 5-year increments to try to capture a bit more some of the extreme events that might occur in these shorter time steps. We started modeling at a higher grid cell resolution, 1 kilometer, and then more recently for the ACMI, 4 kilometers. And then we did complement the work with case studies. So this gets to Carolina's point a bit, that you can't just do the modeling without actually grounding it somehow in studies on the ground. These are the combinations of scenarios we used for the most recent work, the Africa Climate Mobility Initiative. And you can see we had a low and a high emission scenario, which we coupled with sustainability, SSP1, fragmentation, SSP3. Most of you are aware of these. The basic point here is that SSP3 projects a world with much more rural characteristics. This is Africa. So in other words, Africa with much more rural characteristics, and the population difference is something like 500 million people, between 1.7 and 2.3 billion people by 2050. So the sustainability one has lower population, more urban, et cetera. You can't see these, sorry, but the gridded resolution of the data that we use as an input in the ACMI was much higher resolution using GHS-POP, which is a model data set, and the lower version, the lower data set, GPW, is what we use for all the World Bank groundswell work. So that has a much coarser kind of baseline of population. We also improved the ICIMIP inputs, ICIMIP being the Intersectoral Impact Model Intercomparison Project, if you were wondering. So we used a matrix of models, 4 models per scenario, in order to get some sense of the uncertainty in each of the projections. These are the ICIMIP models for crops on the left, crop models on the top, and water model on the right, on the left. And basically, again, everything's washed out, but what you can see is projected to 2050, between 2010 and 2050, average changes in index values here. Blue areas getting moister on the left, wet water, and crops and net primary productivity increasing in blue areas. Obviously, the desert areas, it's against a very low baseline, so you shouldn't take that too seriously. But then the red areas and the shades of red getting worse. In other words, declines in water availability and crop production for the projected future. We do this, however, in 5-year increments, so this is just an average over that 40-year period. We also did flood risk, and this was kind of masking out areas that would be increasingly flood prone, but not completely. It was only 20% of each grid cell that would be affected by that flood risk at a maximum. And then we also use UPSALA's conflict data to kind of, in the historic period, to calibrate the model, and then use the 2000 to 2010 data to sort of project future conflict. That's one area where we really could do better. Because the conflict risks are substantial in Africa, and it's a little bit difficult to project that. So a feature of the spatial data outputs are their ability to answer particular questions for each client. So the World Bank was particularly interested at sort of a broader scale, how many people might be displaced by or move as a result of migration internally. So we have this range now for the most recent groundswell that includes all these countries in dark colors here, of between 48 and 216 million. These numbers are not astronomical. This is, again, internal migration. And you could say that, you know, this is a manageable number in many ways. The numbers are highest as a proportion of population in Africa, owing in part to the climate sensitivity. One nice thing that came out of our model, I won't say it's nice, but it basically shows that the high emission scenario with the least beneficial development scenario ends up having the highest levels of migration, climate-related migration, compared to the more optimistic scenarios with lower emissions. You can create these hotspots maps, and for East Africa, you can see in red areas likely to increase in population, blue areas decline slightly. Actually, they will not decline, but the growth will be attenuated as a result of climate migration. So that's an important distinction. This is not saying that people are going to leave these areas or that population will decline there, but rather that it will just simply be reduced slightly as a result of climate migration. One of the things the bank was particularly interested in is livelihood zones and how people might move out of rain-fed areas into pastoral or dense settlements, and so that was one of the factors. I know we're getting close to time. The Groundswell Africa focus in West Africa was on coastal zones, And so this is just Cote d'Ivoire. These are the future population projections. This is one of the things that you can get out of the model, which I think is important to realize it's not just migration. The coastal zone areas end up being areas of sending areas for the work that we did. And we modeled this at 1 kilometer resolution in the coastal zone. The ACMI defined hotspots. I won't go into the details of how we defined hotspots, but basically these are more high confidence areas where migration will be in or out. This is just binary, in or out, based on certain criteria. But we can also look at the actual change in population density per grid cell within those hotspots. And this is a continentally defined hotspot for Africa. And you can see certain regions where the intensity of the hues is particularly bright, and that suggests that these are going to be high in and out migration. ACMI was very interested in particularly UNDP as one of the clients in borderland areas and what will happen in borderlands. So we see that the Congo kind of Lake Victoria Basin area is on the eastern border of Congo is very high in migration area, but other areas like Mozambique, Tanzania, and Uganda, these borderlands will see out migration, out climate mobility. Pasture lands generally see out migration across the scenarios, and coastal areas first see an increase in climate migration in and then out later. Finally, we have urban areas like you can really drill down into some cities like Dakar region, which is largely an out migration area, climate out migration region, and more movement towards the east. So comparing results, one thing that you will notice is that if you look at the first two hotspots maps, these are from essentially the same model but slightly different resolutions that we ran it at, and the same inputs from ICIMIP, and you basically get the same hotspots. If you start changing the ICIMIP inputs and you start looking at the higher resolution gridded population input, the ACMI work actually produces very different hotspot areas, which if you think about it from, so again, red is in migration, blue is out migration. If you think of it from a policy perspective, this could be a potential confusion for messaging. Red, I see. Last couple slides. So, and thank you, Karsten, for your forbearance. So basically, I think we've been criticized a bit. This is very top-down. It's sort of heavy-handed. In this community, maybe more acceptable. For those who are more into the field-based, ground-based research, it's considered very like demographic, top-down modeling that doesn't really fit well with the realities of the world. However, what I will say on a positive side is this got the topic, I think, on the agenda of a lot of developing countries and developed countries. It's spawning a number of spin-offs. It's complemented field-based research and surveys. And we've run a lot of consultations with the ACMI project, and it's really being used heavily for policy formulation and that sort of thing. Plus, the data are open, so you can go to our NASA data center and now download the data for groundswell at this DOI. And the negative, of course, is that there's an overemphasis on the headline numbers. The model is top-down, as I mentioned. But yet, if you look at most other modeling approaches, they're really not scalable to the same degree. And of course, it can be used in a sort of securitization narrative to keep people out of countries. With that, I will stop, and if I've already eaten into my Q&A, then I'll take the penalty. Thank you.
Thanks, Alex. Yes, you have. So Raja maybe, and then Fabien can already set up during that time.
Alex, I did the review for the very first ground where, and I probably asked the same question that I asked earlier because I wasn't sure. For the baseline, I don't question much about the projections and so on, but you never really established first in the baseline the relationship between whatever climatic factors and internal migration, right? Yeah.
And we need to sort of nail that. Sorry, I guess whoever's online, I apologize. But I think I've already extended my time too.
I think to be fair to the other speakers, I think we have to move on. So, but I think this work builds on each other. If I got that right. So,
yeah, that's correct.
Fabien, please.
Yeah, go to your presentation, please. Okay, yeah. So, yeah, good morning. My name is Fabien Cotier. I'm a postdoctoral research scientist at Columbia, working on the African Climate Mobility Initiative with Alex. I'll be presenting what I would call an extension to the Groundswell project, where we not only, as Alex just shown, like trying to model internal migrations in the future, but trying to also look at how also project international migrations. The scope of this, it's long-term permanent migration, I should say, from the outset, and it's only looking at regional migration, so between countries within Africa. So we're looking at south-south migrations. I'm going to skip on this. So the objective here is to project and understand how bilateral cross-border mobility flow are susceptible to develop on the African continent over an horizon extending up to 2050. And again, we're only looking at migration within Africa, not to Europe, for instance. And specifically, when I examine how crop yields and water flow using ECMIP2B projections may influence future bilateral migrations, and evaluate how population and economic development also influence cross-border flows in Africa. And we do so using a well-known gravity model of migrations in combination with Bayesian hierarchical modeling to obtain better, more accurate projections while accounting for uncertainty in those projections, something we really care about. So, I mean, you're all familiar how we go about projecting, so I will. First, there's a calibration step based on historical data, and the second, you would then project based on the various scenario data you have for, and again, this is mostly population and economic data. Now, modeling bilateral migration flow is a bit hard, as you may be aware of. You need, because factor of origin matters in the decision to leave some country. Factor of destination also matters. Migrants generally look at destination where they may have better income, better labor opportunities than at origins. At origin, of course, conflict might be a big determinant of migration, but also what's known as migration route-specific effect also matters. So this is, for instance, the cost migrants will face. So, for instance, crossing the Mediterranean to reach Europe is very expensive, costs about 3,000 to 6,000 euros, and carries significant physical integrity risk. Migration policies tend to be highly discriminatory. So, for instance, one specific country may let some migrant with a specific set of nationalities in while refusing others. And we care about this because we want to project in the future. So, gravity model is one way of approaching this. It's certainly not the only way, but it's widely used in the literature, although it has some limitation, of course. This is a very naive and simple model of gravity migrations you're probably, again, all familiar with migration being a function of population at origins, about the ratio in terms of economic attractiveness at destinations, and it's weighted by a measure of cost, which here is destinations. And you can estimate this easily using, for instance, linear regression and taking log on both sides. Now, gravity model requires a whole lot of data, especially when you try to project in the future. And this is where things get more complicated because we have only data on specific variable, and we miss a lot of data to capture important aspects of migration flows. For instance, immigration policies, historical legacies. We tend to see more migration between countries which were part of this same colonial empire, for instance, because of established labor migration network that took shape during as a result of colonial policies. Maybe linguistic affinities may also help. And of course, migrant network are key determinants here. So our solution is to use a Bayesian hierarchical model with random intercept for origin, destination, and route directed diet in this sense. And this allows us to adjust our model to account for unobserved heterogeneities in migration outcomes, and also has this nice feature that we have inherently probabilistic projections. So the calibration is a very simple model we use. We use as a dependent variable is the log migration number using stock differences approaches, and we subtract the number of refugees from the total of migrations in the calibration model, because we want to only focus on migration that is resulting from population economic development, but we don't want to look at refugee flows. For explanatory variable, we look at, so I mentioned earlier, crop yields and water availability using the ECMIP2 calibration data. We include a measure of economic resources to capture the fact that migration requires a lot of resources, and the richer a country, the more likely some people may have the ability to engage in migration and support those costs. We include a measure of economic attraction, which is simply the ratio, the GDP ratio between destination and origin, and also a measure of population. Migration network is measured as the population as the migrant stock, T-1. And because subtracting refugee flows only deal partially with the problem of like flows that are related to political violence, we also include the control for political violence and a measure of distance, of course. There's also some time demise, but that's, I'm happy to come back about that. So the sample is the entire African continent, so it's about 46 countries, and the temporal coverage is from 1990 to 2010 at 5-year interval. So we have only 4 years of data. This is the calibration model, but I'm happy to come back to this in the Q&A. Just for sake of time, I'll be moving. So how do we go about projecting future scenarios? So we use ECMIP2B data on climate model impacts for copies and river discharge based on CMIP data. And we use three different scenarios, I should say. So one RCP 2.6, which is an optimistic CO2 emission scenario in the future, and the RCP 6.0, which is more pessimistic, of course. And we compare this with a historical, what's known as a historical scenario, but where we keep the crop yields and river water availability fixed as the average over the period 1990-2010. And this allows us to measure how much more migrants we might see in the future, right? And we combine that with the SSP projection for population and economic development. So we also have like two scenarios. Alex already mentioned. So one is SSP1 sustainability, which is more optimistic. So we have rapid economic growth, lower population growth. And the other one is the regional rivalry, so SSP3, and it's basically the reverse, so lower economic growth and high population growth. Right. I mentioned we use different CMIP5 and CMIP2B scenarios. So we combine the Hadley 2 with the GFDL at Princeton and look at two different sets of ECMIP2B scenarios, the LPGML for crop and water, as well as another set based on the gap for crop and water gap for water availability. That's a whole lot of projections. In the end, we focus mostly on the Princeton GFDL. That would be the result I'm presenting in a moment. And the gap crop water gap set of ECMIP2B projection. And the reason for this is that all the CMIP5 model project increased rainfall over Eastern Africa, but Western trends seems to be rather going in the direction of a drought, and the GFDL ECMIP2B are more consistent with this scenario. So that's why we focus here on this one. Of course, it has some impact on what we find. I'll be happy to talk about this. So some final notes. We project iteratively for each 5 steps of 5 years, and then like update at each time's population and diaspora projections. We used 0 migration scenarios from Sammy Casey and Ellen Benevist for this, but of course, as we use the traditional GDP projection from the SSP, so we cannot really account for the migration effect on GDP developments. We made the decision to keep the political violence variable at its global average for the entire continent. The reason for this is we don't want to use past value, because while past value are highly predictive of the likelihood of conflict in the short term, they are less so over the longer term, and that's actually problematic if we do so. We don't want to keep it at 0 because also not really unrealistic, but this is like, I would say, still a relatively naive way to proceed. And of course, as a reminder, we look here at long-term permanent mobility, and we miss a lot of the more seasonal, more short-term migration. So, and also the data we're using is probably underestimating total migration. So in terms of projections, I show here our main results, and of course it's a bit hard to read. So on the top row you have the projection under the SSP1 scenario, which is more optimistic, and the bottom row under the SSP3 scenario. The left column is total migration projections, and the right-hand side column is how much more migration we would see compared to the historical average scenario. So the historic, on the left-hand side scenario column, the historical scenario is the bar to the left, and we have the SCP 2.6 and finally SCP 6.0, and then we compare how much more migration we may see. Okay, 2 minutes. I'll try to be brief. What we can first notice is that the SSP1 scenario is actually predicting much more migration than the SSP1. It's about 25% more, or about 2 million more migrants. But when once we look at the effect of climate shock, we see that taking account of the future climate change, then we'll see more migration in the futures. It's not huge, depending on the scenario. Under SCP 6.0 would be about 500,000 more migrants. But what may not be apparent here, and I'll skip on these ones, is that these findings are actually highly geographically dependent. So basically in our calibration model, crop yields are associated with migrations, but it's positively associated. So the higher the crop yields, then the more migration we observe at the international level. And this is really driven by the Southern African region, the SADC, where we, under the GFDL ECMIP GEPIC scenario, we see more crop yields in this region, right? So this is why we see more migration, and the effect in the region is actually quite large. Now, when we look at other regions, for instance, West Africa, and we don't see that. Here, predictions are slightly negative for crop yields, and we see a decrease in migrations for this region, right? And going further, for the other regions, for instance, Eastern African community, basically based around the Great Lakes or the Horn of Africa regions, then we don't see much of an effect. Northern Africa, there's an effect, but it's really small, so we can ignore this. So in conclusion, so we find a moderate climate shock climate change impact on migration in the future. This is mostly driven by the effect of crop yields. This narrative is consistent with a narrative that emphasizes that migration is costly, so that better crop yields would mean more resources to invest in migration, right? Those predictions indicate more migration in the futures, but this is actually highly heterogeneous by region, as I mentioned. And it's really driven by Southern Africa. We have no discernible impact of water availability from the calibration model, any of those. And obviously, what's probably the key insight of this model comparing SSP1 and SSP3 is really economic resources matter for migration. We find systematically more migrants under the SSP1. But this is still, I would say, our first attempt. There's a lot of limitations. Obviously, data is based on census, and we know very well that quality of census and frequency of census is highly variable in Africa, so that's the first source of uncertainty. We don't account for effect of climate at destination. It's not clear whether it's really matter. It depends whether it's rural urban or rural migration, of course. The way we update migration stock data in the future could be refined, of course, because that's really a bit naive. We just add the total of new migrants to the migration stocks per origin. And of course, if we look at other sets of migration, then we don't find much of an effect. So that's a big reason to be cautious about this finding I just presented, right? And of course, there's a very naive treatment of political violence. You may just have seen with Ukraine or the Arab Spring. But those major, like systemic shock, they really organize the whole mobility network. And this is something that matters a lot, but we cannot really project in the futures. And at the modeling level, there's two problems, I think. First, people who migrate, they may also consider outside options, which is, for instance, migration to Europe. And this model just assumes this is independent. And in reality, it's probably correlated. So that's a big limitation. And of course, a log linear model is highly limited. It's a model that is really limited. And there's other functional form that could account for count data and access zero in this modeling, in this model that might be better, but it's actually really hard to sample with a Bayesian hierarchical model. With a Poisson log normal, for instance, and we also try a zero inflated negative binomial and also just a negative binomial, but here we got like unrealistic projections. So it's still a little bit work in progress, and I'm happy to respond to your questions and remarks and any advice also.
Thank you, Fabien. Any questions? Yes.
Thanks a lot, Nina van Uskul, Uppsala University Department of Peace and Conflict Research. So I think you already acknowledged that. I think the treatment of political violence is maybe potentially important, I think for two reasons. One, because conflict is such an important driver of vulnerability, and then for the reasons you mentioned as driver of displacement. And I was thinking about two ways of doing that. I mean, if you look into the research on the conflict trap, we actually know that conflict has this persistence. In fact, at least over 10 or 15 years, so maybe at least for the initial period, you could do that in a way where it perhaps you build a decay function or so where it then lowers the risk. But I think at least for this initial period, you could probably do that in a more nuanced way that also accounts for the subnational or country level variation in the countries you study. Thanks.
Yeah, thank you, Nina. That's a very good point. Yeah, a decay function would be actually a much better way to deal. Probably kind of regressing toward the global average. That would be the best way. There's obviously some question about how you parameterize this, but I think, yeah, that sounds like that's a really good advice. Thank you.
Hi, thanks for the nice presentation. My name is Lena Reimann. My question is, I was a bit surprised about the higher numbers under SSP1 compared to SSP3 because we have much higher population numbers under SSP3. So I was wondering, and you said in the end that it's mostly because of economic development basically that we see these higher numbers. Maybe I missed it, but did you also account somehow in the modeling, like in your assumptions for the differences of like this regional rivalry, especially under SSP3, that also then has an effect on how many people migrate internationally?
So the SSP scenario for population we're using a zero migration scenario. So there's projection that's supposed to reflect future development in absence of migrations in that sense. The findings from the calibration model, the results rather than findings, let's call it this way, it's better, kind of suggest that attraction has little of an effect in terms of migrations within Africa, but this can be explained by the fact that the differences in GDP, like in income or wages or labor opportunities between origin and destination are not that huge in the region. But what really seems to matter is this fact that you need resources, you need way to pay the cost of migrations. And the SSP1 really seems to be capturing this dimension that it's easier to migrate if you are from Ghana or Cote d'Ivoire than if you are from Mali or Niger, because you have more resources. Yeah, so did this answer your question, or maybe I missed a part of it?
Yeah, I might just ask you in the break then. But yeah, I will follow up on that in the break. Thank you.
Thank you very much, Fabien. I think we have to move on. So the next presentation will be online. There he is. Hi, Lars.
Hi. Can you see my...
yes, that works.
Okay. Yeah.
Yeah, perfect. Take it away.
Right. Yeah, unfortunately, I cannot be there due to poorly timed COVID infection, but My name is Lars Tielhoff, and I work as a PhD student at the Institute for Environmental Studies at the Vrije Universiteit Amsterdam. And here I work mostly on developing an agent-based model in which we try to simulate household adaptation and migration decisions in their increasing coastal risks. So we'll present to you some of our work on the CoastMove project, in which we try to build a global agent-based model of adaptation and migration decisions in face of sea level rise. So global sea levels are rising, which will affect coastal communities worldwide. So in addition to permanent inundation, sea level rise will also increase storm flood frequency and severity. And the people that experience these changes in their environment generally have sort of three options. They may do nothing and accept a lower quality of life, for example, by more experience of flooding. They may also accommodate these changes, for example, by elevating their homes, or they may implement flood-proofing measures, or they might also migrate away or retreat to more safer locations. And essentially what most larger top-down approaches do not really account for these different options that sort of compete. For example, this adaptation versus migration decision, even though migration is a form of adaptation, people can still stay in the same location while adapting. So each of these decisions is affected by certain household characteristics, such as, for example, risk perceptions, which means if people actually know or perceive that they are in an area of coastal flood risk, but also their wealth, income, age, education, occupation, sex, and place attachment all play a role in shaping these adaptation and migration decisions. And furthermore, if people, for example, adapt, this also changes their vulnerability to future changes in coastal flood risk, for example. So what we do in this model is we try to combine such a top-down approach with an agent-based model, in which we actually try to simulate these adaptation decisions on the household level. And for this, we choose France as a first case study area, because here there are no really big centrally planned coastal flood protection infrastructures. And it also has a highly urbanized floodplain. So what we first did is we divided the area up into the NUTS-free regions and the coastal floodplain. And we then simulate migration between these NUTS-free regions, these inland regions, and from inland regions towards the coastal regions based on the gravity model of migration, in which the basic underlying assumption is that locations with a higher population attract more migrants, which decreases over time. Also, this interaction effect with the location, with the population in the origin region. And we then simulate households residing in the 1 in 100-year floodplain based on an agent-based model. We initiate this agent population using the GHS POP of 2015, and we delineate this flood area using the aqueduct floods methodology and take the 1 in 100-year floodplain of 2080 in a worst-case climate scenario. And in simulating these household decision makings following expected utility theory, we can actually capture these changes in risk perception, but also wealth and income of these households, which we parameterize using local statistics data from the INSEE. We also try to capture place attachment by including a fixed cost of migration. And we do all this to capture and understand these local decision-making processes under sea level rise and future development. And for now, we mean with future development, future population development. So we'll quickly walk you through the modeling schedule of the model we developed. So in each time step, we first update the flood hazard, and we do this under different RCPs. And then we simulate a stochastic flood event in which households that are affected by this flood event update their risk perceptions. We know from literature that people who just experience a flood tend to overestimate the flood hazard, whereas people who have not experienced flood for a longer period of time tend to underestimate this hazard to a point that they barely perceive it. So these updated flood risk perceptions go into subjective utility calculations, in which households calculate the utility of these three options. They may either stay and do nothing, they may stay and implement dry flood proofing measures, or they might migrate to the inland portion of the department they reside in, or they might migrate to another department entirely. So then after that step, we allocate the movers, so the households that decided to move, and we allocate them if they move into another floodplain based on a suitability map. And if they decide to move into an inland area, they are absorbed by the inland area node. And we then also implement the dry flood proofing for the households that choose to invest in dry flood proofing, which then also alters their vulnerability to future flood events. Then in the next steps, we update the population, in which we include natural population growth. For now, we use world population prospect scenarios. But we also, in this step, allocate movers that are projected to migrate following the gravity model. So this is just an overview of what the model currently looks like. I show here a figure of the agent population in 2015 in a small region in the north of France. We see here already that after a spin-up period of 10 years, some households have already implemented adaptation measures. These are indicated in green. And we calibrate this spin-up period based on survey data that we have from the area, in which we try to match the simulated adaptation uptake to the observed adaptation uptake in France. And in the next figure, we did a model run until 2080 under RCP 8.5. You can already see that some households have moved away, whereas others might have chosen to implement adaptation measures. And this also translates into the development of coastal flood risk in this area, where we can see that this dynamic risk perception has a large effect on the evolution of coastal flood risk, which we see that after a flood event, people peak in their risk perceptions and they might move away or they might implement adaptation measures, which then shortly decreases the flood risk. But since this is RCP 8.5, we still see a gradual increase in flood risk, which is a result of both continued in-migration towards the coastal zone and of course sea level rise. With this model, we can also project migration flows. And since the model is not yet fully calibrated, I will not go into too much detail on the number we project here. But we can already see that there are differences under different RCPs. And this is the result of an averaged 50 model runs. We can already see that there are changes in migration patterns under different climate scenarios, which will also translate into the development of population residing in the floodplain. And here we can actually see that this inclusion of household behavior under sea level rise affects the exposure of households that reside in the floodplain, or the number of households that reside in the floodplain. This also translates, of course, to the development of the coastal flood risk, which increases over time and increases most under a worst case climate scenario. But again, these are 50 model runs, and we can see that this evolution of flood risk is not a straight line, but is actually affected by the occurrence of flood events. So we quickly go to some of the future development of this model. So we are planning to upscale this agent population under different SSPs. And we do this to also capture, of course, population development, but also development of future vulnerability. And we will also use surveys, which are currently being done by our colleagues in the COSMOS project to calibrate and validate the decision-making of the agent in the ABM. And currently, we have surveys in France, the United States, Mozambique, Brazil, and Marshall Islands, which we also try to use to figure out what are the most important factors that shape these adaptation and migration decisions. But also to try to indeed validate the behavior of the agents in the model. And in the future, we also plan to include government and insurer agents. Of course, governments can facilitate migration, but they can also choose to, for example, invest in larger scale flood protection measures, hereby increasing the flood protection standard of certain regions, for example, based on the occurrence of flooding. We also want to include insurer agents, which, for example, in some nations can actually incentivize these local adaptation measures, for example, by offering premiums or premium discounts based on the implementation of these flood protection measures. And the next step, we also want to include coastal erosion and saltwater intrusion, because we know that coastal erosion will affect coastal communities, for example, by inhibiting their access to fisheries, or saltwater intrusion might affect agricultural crop yield in coastal areas. So this is also a further development of this model. Yeah, so that was in short my presentation on the Dynamo model, in which we try to develop a global modeling approach of both coastal adaptation and migration in the scenarios of climate and social change. So that was my presentation. Thank you very much. If there are questions, I'd like to hear them, or please reach out to me on my email. Yeah.
Thank you, Lars. We have time for a few questions.
Thanks very much for the presentation, Lars. I have a question regarding other measures. I mean, if I understood correctly, you're looking at autonomous adaptation, right? So household level, and what about hard protection, dikes, for example? I mean, this would definitely affect the migration in both directions, actually. Do you consider that? And do you also change the standards in time?
So for now, we do not really consider that. We do use the flood protection standard of France as defined in the FloodPros database, which I think is currently set at quite low. It's 1 in 10-year flooding for coastal areas. But indeed, this is something that we would want to include, for example, by including these government agents that might reactively or proactively raise the flood protection standards based on their experience with flooding. But I think it's really interesting to also include that in the model. Yeah.
Thanks. If I may follow up on this, I mean, you said you're stochastically simulating flooding. My question is, do you also simulate catastrophic events which might, lead to mass migration and actually people not returning or returning after a very long time?
Yeah, I think that's also a really interesting question. Yeah, we now mainly focus on permanent migration, but indeed we see that catastrophic events that actually destroy homes have a quite a different effect as well on migration, because now people might actually be forced to leave because they don't have a home anymore. So I think this is really interesting also to look into in the future. Yes.
Thank you.
Thank you.
Other questions for Lars?
Thank you, Lars. This is very, very interesting. And a question related to your simulation and how much you consider the individual people with the different characteristics. And because on the same flood or sea level rise, and people will act differently. And for the returning, and if you look at Katrina happened, right? And then most of the people like just move back to the city are very different. And so how just something like that, how you explain that? Thank you.
Yes, thank you. That's a really interesting point. Yeah, this is also why we do these surveys, to also try to figure out what characteristics drive these different decisions. For now, it's not yet included in the model application to France, which is still a bit of a basic setup of the model. But I think this is certainly something we want to include. Because as you said, indeed, these, for example, income differences also determine whether people are able to rebuild their homes or return to these areas, which I think also is an interesting point about Katrina. The population structures also changed after these migration events. Yeah.
I actually have a question. Maybe I missed this, but what are your agents? Are they the households, or do you have any other agents also?
Yeah. So for now, we only have household agents, which are consisted of, on average 3 persons. But for now, it's only households. Yeah.
Okay, and can you say a few words about the implementation? Did you use existing software, or did you build it from scratch, or?
We're building it in Python, and a colleague, Jens de Bruin, he's developed the package in which we use to build this model. But it's based on, we use a sort of similar decision rules to other models that were developed by our institute, but this model in itself is quite new. Yeah.
Okay, thank you. Any last question for Lars? Otherwise, thank you again for joining us online, and We will move on to the next presentation in flesh and bone. Gabriele.
Thank you.
Good morning, everybody. I'm Gabriele Standardi from the Euro-Mediterranean Center on Climate Change. So this is the title of the presentation, a CG model framework for the combined assessment of future migration patterns and economic effects under climate change scenarios. So first of all, let me say that this is a very preliminary work where we define the theoretical framework to understand the most important mechanisms behind it. But of course, this framework needs to be further developed to include, for example, different SSPs and RCPs. Then looking at the motivation, well, we all know that climate change will have a big impact on human societies and economies, and this will have in turn, will create pressure on human mobility. However, so far, the standard economic framework for climate change impact assessment has neglected the importance of the international mobility of labor. But this risks to undermine the economic evaluation of the climate damages. So the second motivation is linked to the adaptation. In the literature, there is a need to include other analytical tools in addition to the standard integrated assessment models to identify potentially important political characteristics which can improve or even worse the adaptation to climate change. Given this, our objective in this work are to, first of all, build a modeling framework able to assess at the same time the economic damages of climate change and the international reallocation of labor in climate change scenarios. And also, we want to evaluate in this context how the interaction between different political and technological dimensions can influence this market adaptation to climate change. And of course, one of these dimensions is the international mobility of labor. To do this, we use a computable general equilibrium model, which is calibrated to the GTAP model by Hertel, and which is derived by the GTAP model, Hertel, and it is calibrated to the GTAP 9 database for the reference here, 2011. Now, the type of adaptation the CG model can capture is the so-called autonomous or market-driven adaptation. So one type of adaptation where economic agents, the decisions of the economic agents are driven by market forces. And in this framework, this market-driven adaptation depends on the interaction of three political and technological dimensions. So the first dimension is the substitutability essentially between labor and capital. This is not exactly automation because the substitution can go in both directions, from labor to capital, but also from capital to labor. Then the second dimension is the trade openness in the markets of goods. And finally, the third dimension is the international mobility of labor and capital. Now, just to give you a quick overview of the CG model, the CG model is based on the concept of representative agents. So basically households, firms, and units of labor and capital. These agents maximize, minimize an objective function subject to some constraints. For example, firms maximizes profits under technological constraints. And of course, when a shock hits the economic system, for example, a climatic shock, the market prices and quantities adjust in such a way that the demand equals the supply and the system reaches the new equilibrium. And again, the decisions of these economic agents are driven by market prices and market forces. Now, this, I think I can skip this. These are just this demand structure in the CG, the production and the demand structure in the CG, the structure of the labor market and the capital market. But this is just to tell you that we are going to use key model parameters to set a high level and a low level for each one of the market adaptation dimensions we have seen before. And now we have 10 macro regions, you can see here, and 3 sectors: agriculture and industry and services. Now, for climatic impacts, we refer to Rosone and Sartori because they estimate these impacts for the countries in the GTAP9 database. So for us, it's simpler to implement them in our CG model. So you can see here, these are impacts for agricultural productivity, corresponding more or less to RCP 4.5. You can see that the regions in tropical and subtropical latitudes are more negatively affected, while regions in the north, they could even experience some productivity gain. Then we take impacts from heat stress. Again, we implement these impacts as productivity shocks on labor in the agricultural industry and services. Again, regions in tropical and subtropical latitudes are more negatively affected. And finally, we take impacts from sea level rise, and these impacts is implemented in the CG model as a shock on the stock of capital and land for the different regions. You can notice that the order of magnitudes for these impacts is smaller than the order of magnitudes for the other impacts on productivities. So basically, as I said, we are going to use key models parameters to set a high level and a low level for each of the market adaptation dimensions, so the trade openness, international mobility of labor and capital, and substitutability between labor and capital. So overall, we get 8 combinations. We are going to implement always the same impacts in the climatic impacts in the reference year. So this is a comparative static exercise because we want to understand the theoretical mechanisms behind this framework. And we see how the economic structure adjusts under these different technological and political conditions. So the results, these are the results for real GDP at global and regional level. And I want to focus on the scenarios on the left characterized by these strong red, orange colors and blue colors. Basically, these scenarios are characterized by free markets in both for both goods and factor of production, labor and capital. You can see that in general, regions in the north, they are increasing a bit their GDP, while regions in the south, they are decreasing a lot their GDP. And this happens because actually this is not only the consequence of the productivity shocks. What is happening here is that labor and capital, they are moving from the south to the north. And you can see also that this is positive at the global, from the global GDP perspectives, because more units of labor and capital will be used in the regions in the north, where productivities are higher, and less units of labor and capital will be used in the south, where the productivities are going to decrease a lot because of climate change. You can see also in the bottom left scenario that there is a positive interaction between, let's say, automation and free markets. So there could be even a GDP gain. Of course, this is not realistic because we include only a subset of climatic impacts and some assumptions about free markets and automation, let's say, are too optimistic. But this is just to tell you about the positive interaction between these two dimensions. But what I want to stress here is that having international mobility of labor is not enough to have this efficient labor reallocation in the most productive regions of the planet. What is important is the interaction between the goods market and the labor market. You can understand this looking at the maps on the, let's say, on the right, top right. If you look at the global GDP change, so these two scenarios are characterized by a disrupted market for goods. In one case, you have no international mobility of labor, and in the other case, you have a high international mobility. When you move from no international mobility to international mobility, actually GDP losses get worse at the global level. And this happens because labor is not moving toward the most productive regions of the planet. So we can understand this even better if we look at the geographical labor reallocation. So the green bars here basically are the scenarios characterized by free markets for both goods and factors of production, labor and capital. So in these scenarios, labor is moving in the right way, let's say. So from Southeast Asia, South Asia and Sub-Saharan Africa to Europe, rest of the world, and North America. But this doesn't happen in the scenarios characterized by disrupted markets for goods, because what is happening here is that the consumers, for example, in some of the tropical, subtropical regions cannot substitute the domestic product with the imported product. So the consumer keeps demanding the domestic product, and the firms react requiring additional units of labor and capital to satisfy that level of demand and to compensate the productivity loss. And in some cases, it can happen that some units of labor could flow in these regions, but this is not actually efficient from the global GDP perspective. So a similar reasoning can be applied to capital. Now, in this framework, it is also possible to analyze the sectoral reallocation. In general, we observe reallocation in all scenarios of the agricultural production from tropical, subtropical region to the regions in the north. And also, at the global level, in the scenarios characterized by free markets, we observe a reallocation of the global production from agriculture and services. We can see here in the bold type. Anyway, I'm going to conclude. I mean, the most important conclusion of this work is that a free global market for goods is a necessary condition to have an efficient labor reallocation toward the most productive regions of the planet, so toward the northern latitudes, let's say. And when the markets of goods is disrupted, it may be that in some cases there could be a chaotic migrations where basically the workers, the price signal do not drive the workers in the most productive regions of the planet. So as a policy implication, I mean, the main policy implication is that a global labor market, even if we know that this poses tremendous political challenges, will probably be a very useful tool to reduce the economic damages of climate change through this autonomous adaptation of the workers. And so climate negotiations should take into due consideration these aspects linked to the immigration policies. We also observe a positive interaction between free markets and substitutability between labor and capital. So this can be interpreted as automation in some cases. Then, of course, we acknowledge the fact that we only consider market-driven labor migration, so you know better than me, because at the end I'm just an economist, that migration is a much more complex phenomenon, but at least in this framework we are able to set the political and technological condition in which these markets operate and interact. Then, as a further development, of course we should move from a comparative static scenarios to a dynamic scenario, up to 2050 or 2100, and of course we have to extend the number of impacts, and also the most important development will be to include different RCPs and SSPs, and in particular to map the different adaptation dimensions we have seen here in the different SSPs. Also, another aspect which can be further investigated is transfers from developed to developing regions, and this can be done in a relatively easy way in this framework. And with that, I think I can stop. Thank you very much for your attention.
Thank you, Gabriele. Questions? I have one. Well, there's one in the back. Let's start with that one.
Thank you very much for the very interesting presentation. My question here is that the model framework, or you may already have done something with the climate policy. Say, for instance, carbon tax may affect the trade and productivity and in different parts of the world, and how that can affect the migration patterns.
Thank you very much for the question. Yes, this is a good point. Actually, this framework so far considers only adaptation, but in general, you can also implement mitigation policies in this framework. So in principle, it is possible to implement carbon tax and see the interaction between these international mobility dimensions and the climate policies. But this is something which I need to further explore, and I think it will be very interesting also to analyze this aspect. I don't know if I answered your question.
Other questions? I was wondering whether your mobility of labor only refers to migration, or does that also include the case where you have basically the same job getting replaced, so that basically the job moves but the person doesn't move? You know what I mean? For example, the German car industry gets a lot of parts from Ukraine. So now they're of course looking to other parts in the world where they want to buy these parts, and then you have the same job but another person is doing it. Is that also included in your definition of mobility of labor?
No, actually it's an economic, it's just, I would say, migration, labor migration, so units of labor used in other countries. So I don't think that this aspect can be. Actually, this is a good point. It's an interesting development.
Because not just for the Ukraine case now, it's also something that we've seen for a long time in the past, that jobs disappear in Europe, North America, and move to Asia, and now within Asia to countries with lower wages. So maybe that's something to consider for the future.
Yes, for sure.
Last chance for a last question for Gabriele. Otherwise, thank you again, and let's move on to Lena.
Thank you very much for having me here today. My name is Lena Reimer, and I said that already. And I'm actually a colleague of Lasse, so also who couldn't be here today because of COVID. So if you have any questions regarding the Coast Move project, also feel free to approach me after the session. But this work that I'm presenting here today has been, or I've done this work before I started working on the Coast Move project, so that's preceding work. And in this study, we are exploring spatial feedbacks between sea level rise, different adaptation policies, and migration. And we apply the RCPs, SSPs, and also SPAs in this study. Yeah, so coming from a coastal flood risk perspective, the main drivers of sea level rise impacts are on the one hand side, the amount of sea level rise to be expected in the future. Then on the other hand side, the socioeconomic development and the number of people exposed to sea level rise, but also adaptation strategies that are implemented. And these are actually rarely, or the spatial, the uncertainties of these drivers. So how these may change in the future are rarely accounted for in coastal impact assessments. If we do not account for that, so if we do not account for people migrating, for example, because of sea level rise, we potentially over or underestimate future flood risk. So the idea was to explore a range of different sea level rise, socioeconomic, and adaptation scenarios, and see how these then affect migration patterns, not decisions, because that's what we're doing in Coast Move now. And the focus of this work, and this is, I think, important to point out, was to explore the effect of different adaptation policies on internal migration patterns. So we do not account for international migration. We account for 3 types of coastal adaptation strategies. So on the one hand side, we include protection, hard protection in the form of seawalls or dikes, then accommodation strategies, and also retreat. And all of these 3 adaptation strategies can be either autonomous, that means they happen on an individual or a household level, or they can be planned, referring to the policy level. And this is what we particularly focused on in this study. So the goal was to explore the effects that different adaptation policies may have on sea level rise induced migration. And so the first step actually in this process was to develop shared policy assumptions for adaptation policies. So that was the starting point. And I developed 3 different broad adaptation policy assumptions, which are build with nature, save yourself, and hold the line. And I think the names can tell you already quite well what kind of assumptions are behind those scenarios. And then in the next step, we interpreted these scenarios, or we filled these scenarios with assumptions based on the SSPs. So we combined them with different SSPs which would fit best to the adaptation policy assumption. And so we decided to use SSP1 for the build with nature scenario, SSP3 for save yourself, and SSP5 for hold the line. And then in the third step, we combine those with different sea level rise scenarios based on the RCPs. So in total, we are looking at SSP1 compared to combined with RCP 2.6, SSP3 with 4.5, and SSP5 with RCP 8.5. So those are the scenario combinations that we used. Here you see the coastal adaptation policy assumptions that we developed. I want to focus your attention to the last part of this table. So the upper part of the table has the global SSP assumptions as developed by Brian O'Neill et al. And we use those then to develop our adaptation assumptions, and the adaptation strategies that are implemented in each of the 3 scenarios. For the build with nature scenario, we have managed retreat. Setback zones are implemented in areas that are regularly flooded due to storm surges. Then the restoration of coastal ecosystems in areas where ecosystems actually exist in order to keep their protective function when it comes to sea level rise related impacts, and then protection only in densely populated locations. So that was the first scenario. Then save yourself is mainly a household level kind of scenario, so people have to basically adapt themselves. So with household level protection, also autonomous retreat, and the protection in the form of policies that actually implement protection strategies only limited to high-risk locations. And then the hold the line scenario has mainly only hard protection strategies and large-scale solutions, so policies focusing on building hard protection measures. We implement this, or we quantify this in the Mediterranean region. And for those of you who've seen my presentation yesterday, I use the same modeling approach that Alex just introduced, so that's nice. I can go a bit quicker over that. And I extended the model to the Mediterranean region, and that's and the reason for that is that there are high population densities and urbanization levels at the coast, which makes it very interesting to study when it comes to sea level rise, and also there are large differences in adaptive capacity across the region. So the gravity-based approach, it's the same figure basically that Alex showed. I extended the model, and I think that's all I need to maybe explain right now. I extended it to the coast by accounting for coastal and inland migration as well. So the model, as it was developed initially, accounts for rural-urban migration, and this version of the model also accounts for inland coastal migration. And I calibrated and validated the model to the Mediterranean region, differentiating northern versus southern and eastern parts of the region. So what I then did in this study, so that was the basis, was the conclude model, the extended version of the model. I used that, and I combined it with different spatially explicit assumptions for adaptation. So the protection, accommodation, and retreat assumptions that I just introduced, we modeled those spatially and added those to the model to then be able to see which areas are permanently inundated because of sea level rise and which areas are prone to storm surge flooding because of sea level rise. But what we looked at now in this study is only migration because of permanent inundation. So based on this, we could then derive the number of migrants because of sea level rise and the different adaptation strategies. And we did that in 10-year time steps and compared this to a no sea level rise scenario and a no adaptation scenario. So the no sea level rise scenario, the comparison would then be to actually see what sea level, how much migration sea level rise produces, and then the no adaptation scenario, then to see what the effect of the adaptation policies are on these migration patterns. And yeah, so here, I already expected that the yellow line is not very easily seen, but I think that's okay. What you can see in this graph is the number of migrants until the year 2100 in the entire Mediterranean region, and the solid lines, which are pretty much along similar, so the yellow is also along those lines, show no adaptation strategies and how many people would migrate then. So it would be up to 20 million migrants in the Mediterranean region until 2100. And then the dashed lines show the different scenarios. So under the Save Yourself scenario, which is SSP3 combined with RCP 4.5 and very limited adaptation, we would see most migrants. And under the Hold the Line scenario, where we have large-scale protection, we would see much fewer migrants. Yeah, now this will be a bit tricky, but I will walk you through the main message of this slide. So what we see here, maybe, is the lack a lack of adaptation policies leads to out-migration from the coast. So this is the scenario just looking at no adaptation at all, combining SSP5 and RCP 8.5 in the year 2100. So what you should see is pink colors in the coastal zone, so but they are also, to be honest, it's hard to see them also if you saw these slides a bit better, because it's a really narrow coastal strip where people leave, and then they are distributed all over basically the countries, especially in urban areas. Then, yeah, good. So this is actually not too bad, because this is exactly, so here we see the hard protection measures and that they reduce migration intensity. So what you were supposed to see in the previous slide, this effect is dampened by including or by protecting with hard protection measures, which I guess is understandable, because people will not have to migrate basically because they are not affected by sea level rise. This changes, and now this slide was supposed to show how migration patterns differ when you have no adaptation versus the adaptation strategy. So under the Hold the Line scenario, you can see here, for example, in the Nile Delta up here, a green spot, which basically means that in those areas more people live under the adaptation scenario than there would be under no adaptation. And I think also that makes sense, because those areas that are protected, people will just not have to move. And we also calculated migration hotspots similar to the approach that Alex presented. And what we found here, and this is the main message, that there are many migration hotspots that are actually independent from whether adaptation policies are implemented or not. So we see these hotspots, which are, you see at least those red dots or red patches that show up no matter whether we account for adaptation policies or not. Under all scenarios, those show up. I want to briefly mention that it's very important to also contextualize these migration numbers based on the socioeconomic developments under the different SSPs. Because these scenarios now look like under SSP5 combined with RCP 8.5 and the Hold the Line scenario, we don't see many migrants, so this would be the preferred scenario, right? Because not many people will have to move. But there are, it depends, so basically what it results in is that many people live behind dikes or behind protection measures. So in the case of protection failure, the residual risk is very high under this scenario. So and under the build with nature scenario, for example, we see many migrants, but this migration is proactive migration, and in case of sea level rise or storm surge flooding, fewer people would be at risk. Very quick summary of what I just presented. We extended conclude to allow for exploring the long-term spatial feedbacks between sea level rise adaptation policies and migration. And we see that adaptation policies all reduce the number of migrants and they reverse spatial migration patterns, especially, of course, here the dikes that I mentioned, so the so-called levee effect. Conclude allows for accounting for additional impacts and other variables. This is also what Alex presented. So this is like closely connected. And the manuscript is currently under review. These are the collaborators that I would like to thank. And thank you very much for your attention.
Thank you very much, Lena. Let's start here in the front.
Thanks, Lena. This is really, really great work. I had a couple clarifying questions. One, when you attribute the different adaptation policy scenarios to each of the SSP RCP combinations, are you able to kind of do a check that the policy set that you attribute allows to be in the scenario, the SSP RCP scenario that you are in? Like when you say build with nature for SSP1, does the build with nature set of assumptions allow you to stay within the SSP1 RCP 2.6 framework? Or is it like not enough because RCP 2.6 is not that little or something like that? I don't know if that makes sense.
So, I mean, we only account for adaptation. So there's no effect on like the climate change signal, for example. So I guess it's more about it, I think the decision was more about whether these policies are then consistent with the descriptions in the SSP narratives than it is so much about the sea level rise signal, because we do not really, with this work, we do not account for changes in sea level rise, basically. I mean, changes we could have because of mitigation. So I don't know whether this answers your question.
Yeah, it does. And then the other thing was when you said you account just for permanent inundation, but not coastal flooding, I was wondering whether you could comment on how do you think the results would change, in which direction? I'm thinking of the paper by Andrew Bell and a zillion authors where they found that more people are moving into regions that get periodically flooded than you would think people would leave, and actually more people come in because of other drivers of migration.
So I think this model in general, I don't know whether it would work well with this temporary flooding, like projecting migration due to a temporary flooding, because people can move back. And I think this is not what this model is good at, let's say. So I think it's, I think I should only account for inundation because that is permanent migration, right? But I also have, there's a master student that I'm working with who is looking into these things a bit more. So she also accounts for storm surge flooding, for example. But yeah, I think this modeling approach is better for just accounting for inundation, permanent inundation. I don't know whether this is a satisfactory response, but.
I think there was another question in the middle. Roman.
Hi, thank you very much, Lena. This is really very fascinating. I have a question about whether you tried out also a combination of different adaptation directions, because I'm thinking in reality what we see maybe a little bit more diverse, so maybe different regions could adopt different adaptation policies, and you may also see combinations of those, and I was wondering if you have played around with those. And then a related question, whether you also tried out to be a bit more flexible with kind of connecting the SSPs and the SAPs to kind of show more how on the different pathways of socioeconomic and climatic developments, different adaptation policies may produce different results. Thank you very much.
Yeah, these are two very good points. about the combinations, so the idea of the work was to look at these integrated scenarios or adaptation scenarios. So that was the main aim. And then because we account or we compare to a no sea level rise and a no adaptation policy, we still can, we still have this comparison. So that was, so we've been thinking about modeling just individual adaptation strategies, for example, to see what the effect of those would be. But then the question is how plausible would this, and I guess we can discuss about the term plausible, that was at least raised yesterday, but how plausible these combinations then would be with the individual SSPs. So the idea was really to develop adaptation policy assumptions that go well with the individual SSPs. And your first question, can you repeat that just very briefly?
So if you have tried also different combination of adaptation policies across space and also similar locations having different...
Yeah, so what I didn't mention is that we use different assumptions for the northern and the southern and eastern parts of the region. So that's one thing that we accounted for, basically assuming that adaptive capacity in the south and east is lower than the north. So adaptation uptake would be a bit less strong, let's say. But then, of course, you could also, so basically we just assume this is the adaptation policy and this will remain the same until the year 2100, which is also, I guess, a very simplified assumption that now it's being implemented and then it will just remain like that. So there's a lot that can be done, I guess, in this context, but I haven't done it.
Okay, thank you.
Okay, so there was Carolina and one in the back and Alex. Yeah, of course. So, yeah.
Sorry for not sorry. Thank you for very much. Thank you very much for a very interesting presentation, and I really like it, but I'm just thinking whether it is even possible to add somehow the aspect of technological development, because this actually influences somehow adaptation possibilities. And in such a case, it would be probably visible the comparison between north and southern Mediterranean coast. And then the question is whether the sea level impact you are looking at is just the flooding during the storms and so on, or it's also intrusion of sea level waters into the land, which actually also cause this degradation of soil, and those who are living nearby push, you can see it easily in Tunisia, for instance. And the third thing, if you are looking for delta of a Nile delta, like the dam in Ethiopia, Millennium Dam, it's going potentially to cause huge influence on Nile delta, which is already decreasing actually. And I'm wondering whether you have included it, because the Alexandria, I think that was the green one point.
Yeah.
And so that was the green one, which is protected, and the delta actually is decreasing.
Yeah. I think, and I think this responds maybe to the two of your questions, the more localized effects. I think this is not the right modeling approach to do that. So the agent-based model that we're developing now will account for these, like for erosion and saltwater intrusion and so on. That's why I just went with permanent inundation, basically, because these local scale effects cannot be captured in the model. And your first question was, technological change. There is assumptions on technological change that we use based on the global SSP narrative. So there are assumptions, but this is, of course, like very broad assumption, just high technological change, slow technological change, basically. But those are accounted for in our assumptions to make this consistent with the assumptions in the SSPs.
So there was one last question in the back.
No, thanks. Yeah, but very, very interesting stuff. I have a very detailed question, so I might shift that to the coffee break in the interest of a general discussion. Great stuff. Thanks.
Thank you very much. Yeah.
Maybe Carsten, you have some comments. Thank you, Lehman. Lena, that was really wonderful. I have just a general observation. I think we can continue the conversation over lunch and whatnot, but I think one thing we should all be sort of thinking about is how our models replicate actual migration decision making. Obviously, the ABMs are intended to be more true to what individuals or households think about when they actually consider different options. Actually, as a sort of shameless plug, we just wrote a piece in Frontiers in Climate that looks basically at the application of migration theory from all disciplines, sociology, geography, et cetera, to the specific question of climate mobility and whether or not the studies that are out there are actually drawing on the best migration theory or using very simplistic push-pull models, which tends to be what the modeling community currently is kind of using. And that's obviously the Groundswell and others are tending to lean on heavily on these kind of more simplistic models rather than more sophisticated things like aspirations and capabilities, or even these socio-ecological models, which are really pretty complex but capture better what's going on in kind of local, like the kinds of things Carolina was talking about, what people are actually considering when they think about where they want to move and the kind of options available to them. I also think some of the issues, like Lena would be able to speak to this more, but the issues around conflict and the potential for just really disruptive futures. Can we really talk about climate migrants per se, rather than just the kind of what I'm calling increasingly the messy middle between voluntary and involuntary migration, direct displacement from conflict and extreme events versus, the kind of neoclassical model of people, homo economicus, making the best decisions for labor allocation, things like that. And I think that messy middle is going to be increasingly characterizing what we're going to see in the world and in parts of the world where we're already seeing the breakdown of governance systems and things of that sort. So these are just things that are going through my mind as I'm thinking about how realistic are these future projections and can we really have much confidence in them. I've tended to be sure to say to our World Bank colleagues and others that these are not predictions of what's going to happen in the future at all. These are just basically plausible futures, but there could be a lot of other futures that we just can't imagine. Did you have some other thoughts, Carsten, on the sort of?
Well, my thinking was, it was really interesting to see all these different modeling approaches. Given my background, I'm of course particularly excited about all the spatially explicit work that's going on. But I think we are reaching a point soon where it will be time to write some review papers and check exactly the things that you've been talking about. Which kinds of models are good at capturing which type of theories that we know from migration theory, things that describe things well that are going on in reality. I think the models all have their strengths and weaknesses, and if we do this comparison at some point, then we should have a better idea of also how to interpret these model outputs, because we keep saying what you just said, right? It's not going to happen like that. It's just one of many plausible futures. But linking it to the theory might be a good way to be able to explain what the particular strengths and weaknesses are.
Yeah, maybe I feel like it's worth having a little more audience interaction at this stage, even if we're eating into our lunchtime a little bit. So.
Yeah, I was wondering, there was a lot of discussion yesterday about the MIPS, all the model intercomparison projects. It sounds huge, and I don't know if it's a good idea for this type of work, but I was wondering what everybody's thought was about comparing responses to similar questions, but with very different types of models, or comparing responses to different types of policies, the way Lena was presenting, and where she found that she still found the same hotspots. Those are messages that I feel that's the only degree of robustness that we can get across the whole field anyway. So that would be the part that would be most policy relevant, I guess. I don't know if it's something that this venue would organize.
So climate mobility MIP. Anne, did you have a question or a comment? Sorry.
Yeah, just a small comment. I think also what it points out, and maybe it was not talked about during this session, is about the concept of trapped population. So like the negative of migration, which is the people who don't have a means to migrate. And I think like some parts of the research that migration scholars do should look into this as well. That's all.
I would have a comment that goes into this direction of uncertainty. So there are many factors that we are trying to capture with different models. It's fantastic work. And I'm wondering like how much actually we can, how to communicate it also to policymakers, because it may give an impression that we know where people would go, they may take it as a prediction, while we know very well that there's a huge aleatoric uncertainty in migration decisions. And even the same, we tend to think that if you bring down the people into more boxes, more granular boxes in their characteristics, we would be able to say who will move and who will not move on what decisions people would take, while we don't know because there are many other factors like risk. Some people are risk-averse, some people are more risk-seeking. We see it also with refugee moves that some people start fleeing even if they are like in different part of the country where there is no combat yet because they're just afraid. Some people stay as long as possible in horrible situations. So this is more just a comment, like how much we can actually explain with our models and how to make policymakers really aware about this like fundamental uncertainty that would always remain when we try to forecast or make some illustrations how future migration may go.
These are really good points. Did you have something, Fabian, you wanted to add?
Yeah, somewhat related to a lot of those projections are scenario-based, which means they are conditional statement about the futures. But sometimes it's hard to really differentiate. Ideally, we would have like probabilities between those scenarios, and we could get like unconditional statement about the futures, which would probably be easier to communicate to broader audiences, which may not know exactly how likely are different scenarios, and I think that would be a good thing. But that's just something.
Yeah, this is something that often, if you've got a matrix of 10 or 15 different scenarios, you just throw it out to the decision maker, and we talked about this a bit yesterday on the bus. It's just, sometimes you need to actually assign some probability, and that's one of the struggles we've had with the Africa Climate Mobility Initiative, is they actually want to make policy in Africa based in part on the work we did and also field studies by the Mixed Migration Center. And I feel queasy about it at some level because I think that, these issues of the trapped populations and the people who have no options, the actual field work that I didn't get to cover in the ACMI really focus, a strong conclusion is that people do not generally want to move. They want to stay in place, and place attachment is very important. So I think factoring all these things, thinking about what measures other than just improved crop varieties or whatever for crop production, but social protection measures, crop insurance or index insurance or other things that can enable people to weather the storms that come along in terms of drought or sea level or whatever they may be, the impacts, so that they can actually recover and continue. But I guess we've gone over a little bit. I think this was fruitful. Did you have a last comment, Carolina?
Yes. If I may. Thank you very much for this opportunity. I was like, through all those 2.5 days, I was looking for the answer for the question, actually, what for are those all scenarios? What for? What's the reason for them? And actually, when we are looking for global scenarios, and actually policymakers, they are seeking for the answer how many migrants will reach Europe and so on. But actually, my impression is also after listening to today's presentation and also basing on the chapter that I'm already finishing on the influence of dam construction on people living in a distant area of this dam. Actually, it would be very interesting to focus not only on a global or a big regional scale, but also Europe and developed countries are going to spend a lot of money for different adaptation investments, and actually to make scenarios what big scale of such investments will be if we will make small dam, huge dam, not only for those living in a close area, but also in a distant. And it's not only about dams, it's all about the solar plant or any other actually huge investments that influence people living in the area. And this is where scenarios may have direct impact on whether the investment is going to have place or not, or what kind of compensations or benefit sharing should be implemented later on.
That's a great point. I'm going to make one last statement, and then Karsten will close us. But there is a new section of Frontiers in Climate, which I'm the chief editor of, and there's a few people here who are, associate editors and whatnot. So this might be an opportunity actually to do a special issue on something like future projections and look at, comparison among model types for given areas. We took this first initial step for our own modeling work for East Africa, but I think there's a lot more to be done in this area to see how sensitive these models are to different assumptions. Karsten, final word.
Okay, then I'm also going to close with a shameless plug.
We're good at that.
So our future migration scenarios for Europe project is in the final year now, and we're planning to have a final conference in Brussels in April, May next year. The date is not fixed yet, but we have a mailing list at futuremigration.eu, so sign up for that, and then you will be posted about the date and exact venue. So thanks to the presenters again. Thank you all for joining. Enjoy lunch.